All right, so we got everybody. So today we're going to slow down a bit, which I'm sure everyone is probably happy about. Looks like Clayton got his network issues worked out.
I did. Can you hear me all right?
Yeah, we can.
Okay.
um, but we're going to slow down a bit and kind of do a deeper dive into stuff. I want to take this opportunity tonight. Um, we'll still go the whole time, but I want to take this opportunity to drill down into some of the details, but also to rehash conceptually what we've kind of learned up until this point. Because week one we did tool chain stuff with Docker and everything. Week two, we did the back end, which was probably just a massive dump of information, right? Especially if you guys weren't used to it. Week three, an even bigger dump of front end engineering, which is a whole nother ball game. And so we're on week four now, and so I want to make sure that we one didn't go too fast, but two, to really solidify some of the things we saw. Because I've noticed that pedagogically, when I've been teaching these things before, particularly in a college class or even a graduate level course, I like to expose you to it from a software perspective first before actually, taking a step back and starting to talk about the words and the vocabulary and some of the patterns and stuff that we see. So I'm going to go through a presentation here. Eric will have recognized it because it comes from some of the stuff that I teach at UTD. And then what we'll do is we'll go a little bit deeper into some of the back end today. And we'll talk about OpenAPI, we'll talk about specifications, we'll talk about RESTful web services, and the things that really drive all the systems and how they communicate, and how I believe every system should be at least conforming to some extent. We'll talk about other APIs too, within the context of healthcare and of course automotive and stuff like that. But kind of what we're seeing. So that is tonight. As always, stop me at any point and ask questions. All right. So tonight, talking about HTTP APIs, HTTP again. Oops, OpenAPI and other stuff. So there's two different types of system communication, which we've kind of learned about, right? One of those is remote system communication, and what I mean by that is, systems that communicate outside of basically your physical location, right? So this would be the internet, wide area network. Sometimes you'll hear about WAN, those types of things, and then local system communication within the context of IoT. I mean, this could be Bluetooth, could be wideband frequency stuff, RF, in terms of short range, 900 megahertz sort of stuff. RC cars are a good example, and typical like Wi-Fi, you would basically count as a local system communication. And so we've been really talking about the combination of these things, right? And we haven't really talked about in depth what you would necessarily use with autonomous vehicles. That will come in additional modules and stuff. But really, I mean, you can imagine that, especially in the context of autonomous vehicles, these communication schemes, both of them are used in pretty serious ways. I mean, remote system is going to be all that, whether it be GPS or LTE, all those things that you basically do to the cloud. And then communication you do with the cloud. And then the local communication is going to be all the local stuff. So you could even consider CAN, being a local system communication. The CAN bus on the vehicle, Bluetooth on the infotainment systems, even IP in the car. You'll see like BMW i7 platform is an IP-based vehicle communication scheme. So there's a number of different things, but I wanted to really call those out. And so really, taking a step back, we talked about this in the first lecture as an introduction, but now that we've kind of been exposed and done a lot of these things, where do we actually start talking about physical communications? And those, starts with the embedded systems. And guys like Clayton deal with these every day, right? You got the low level, UART, SPI, ADC, GPIO. A little bit higher level, you might consider LIN and USB and even CAN, a little bit higher level. And then you got your network interface cards, so that deals with the IP stack. And then you've got, of course, the wireless with the 802.15.4, which is, if anyone's heard of Zigbee or Z-Wave, that's a mesh IEEE standard. Wi-Fi is 802.11, and then you got like BLE and which is Bluetooth, and NFC, near field communication. Then, of course, with our laptops, which we're, I think, probably all on right now, you got either your wired or your wireless, right? Wi-Fi or Ethernet, 802.3. And then the cloud is all network interface, right? All IP and all that kind of stuff. Very, very homogeneous in that. So when we talk about this, how does the internet actually work? Now, when I go into this, you're going to see a lot of things that you should have seen already, because you should have been watching my network video. So a lot of these slides come from that, but I want to make sure that we really solidify this, and we really talk about it. I also want to give you guys an opportunity to ask me questions as I go through it, and do this a little bit live, and I'll probably go into depth, a little bit more depth than is it. So how do we actually, visit on a web browser? Well, last week, now that we've actually been exposed to this stuff, last week we actually learned what the transport layers were doing, right? We actually talked about, hey, there's HTML, there's JavaScript being shipped from a web server, a cloud, right, down to our browser, and the browser interprets that code that anyone can read, and it either displays itself as a web page like Google in HTML with some JavaScript, or it acts as just an interface mechanism with JSON object notation, JavaScript object notation, so JSON, or XML if you've heard of XML. And so that's really how that works. Well, we haven't really talked about it, but what is the actual anatomy of a URL? And I think I'm starting to really focus in here, and I go over this, of course, in my in our prep video. But this is where it starts getting important as we start moving more and more towards deployment and production systems, and really start looking at all the different microservices and how you make those things communicate, and especially as we get into APIs and defining those. And so the anatomy of the URL is pretty much made up into 4 parts, right? You've got your protocol, and this is going to start to become really important because so far we've only used HTTP, but well, we've actually used TCP once, or you probably did if you followed my example, I think in this video, of that TCP socket server. So you actually use TCP there, but in a couple of weeks we'll use MQTT, which is a very popular IoT-oriented pub/sub network, publication subscription network. That's still IP, but its protocol is MQTT. You'll hear WebSockets, which we'll talk about, and a few other things. And you've got www. That's going to be, well, the www, we all have heard about it, right? I mean, we're all of the generation that, as kind of grew up in this www world. That's actually legacy. It's really a subdomain in the end. You don't really need it, right? I mean, we all kind of know that. You don't actually need the www. If you set up your own domain name, which we'll do in a couple weeks, and doing all that, that's just a subdomain that you direct towards your domain name. And so in this case, your domain name would be google.com, and that .com, .org, .net, that's your TLD, your top-level domain. Those are managed, of course, by ANA and IANA, and the registrars, and they map to an IP address. It's just a name, right? That URL is just a name. It really actually correlates to an IP address, IPv4 or IPv6. IPv4 being 16-bit, IPv6 being what is it? Why am I blanking? I think it's 32-bit or 64-bit. IPv6 is, so someone can look it up and correct me, but basically it's just a longer form of it, and everyone's seen an IP address. I'm sure you've all dealt with IP addresses to some extent. But the basic idea is that domain name just points, it's just a human readable pointer to that IP address. And IP addresses are leased to, there's a finite number of them. IPv4 definitely, not so much IPv6. There's could be trillions of them or more.
128-bit.
128-bit. There, yeah, truly trillion. Gazillion. I mean, we'll never reach that many. I don't even know if you possibly reach that many devices. But the idea here is that the basic idea here is that that domain name maps to these IP addresses, and these IP addresses are leased, and they're managed by ASNs, autonomous system numbers, which are given to organizations and ISPs, internet service providers, and at that point, then that's how you get a public IP address. I'm sure you all know your IP address. If you have a home network, it probably looks something along the lines of 192.168.something.something. That is the IP address range, the local range that's been allowed. And you might, the fact that we all have that same IP address sounds kind of weird, right? Well, it is, but not really, because those are not meant to and can't be public IP addresses. If you say, if you type into Google, what's my IP address, Google will give you what Google thinks is your public IP address, and that's the IP address that's behind your router. And then your router is what's leasing IPs then to your local machines on your network. We'll talk a little bit more about that as we go, but that's the basic strategy. And so when we, in the cloud world, when we talk about IP address, we really mean that public IP address. Because that public IP address is really who you are. That's your identity as a server. And then there's a lot of load balancing that you do in order to direct and all that kind of stuff. So, how does the DNS work? This is pretty important. And the reason is because there's a lot of interesting security implications to this. In fact, misconfigured DNSs are the biggest problem with distributed denial of service attacks. Because you can get reflection and those types of things, amplification, and those types of things in cybersecurity. I won't go into how that works necessarily in this. In a couple of weeks, we'll talk more about cybersecurity and the different things you have to be considerate of. But for the most part, DNS is one of the more interesting and older things, systems that just seem to work. And it's quite amazing, actually, if you think about it. So basic flow here, right? Human enters the URL. Browser makes a call to the DNS, and then DNS responds to the browser with the IP address of it, and then the browser makes the official call for the information, which corresponds to a server somewhere. Now, I went through that fast because I would have already said this in the prep video, but now that you know what's going on, if you think about it, we've always been just hitting localhost, right? And localhost actually maps to an IP address of 127.0.0.1. In fact, they're analogous. You can put either one into your browser. And then we run our services on a port. We've been running our services on what, 8,000 or 8,500 or 9,500. We've been running them on those ports. Typical port that everyone kind of agrees on by convention is port 80. So when you actually enter a like google.com, the browser is assuming it's google.com port 80. Not really, actually, because there's a secure socket layer, or TLS, in the middle of that. We'll get to that in a few minutes. But really, there's a convention. And so the reason you may be like, wait, what's going on here? Why don't I have to do a port if I'm just going to the internet? Well, because we've all kind of agreed that port 80 or 443 is the standard port by convention that we use to communicate. Okay, so what's going on under the hood? Well, you got your protocol, like we talked about, HTTP, and then you've got your IP address. That IP address corresponds maybe to google.com, and then you've got that port, what I just described. And so if you were using an unsecured connection, so an unencrypted connection, that is the IP, that is what you would type into your browser, and you could probably get google.com. Chances are, though, Google does not allow that. They're big supporters of what we call HTTPS, which you probably see, that little S behind the HTTP, which you should always be cognizant of. And we'll talk about that in a few minutes. But really, you probably won't be able to do that. It'll probably redirect you to port 443, which we've all agreed is a secure socket layer. So before we get into that, the idea here is that in all of this IP-based communication, there's a pretty sophisticated stack. TCP/IP actually is somewhat related to what we call the OSI model. The OSI model is a set of standards that has really been defined and for the most part is implemented very consistently In fact, you'd probably say is extremely consistently, because we all tend to work on the internet, right? It's amazing, actually, that it's all kind of come together. And it's all this big stack. And so at the very top, which is where we live, is in HTTP. You got your application layer. You got things like FTP, which I hope you never have to use again and will never use again. Please don't use FTP. Don't use SFTP. Please don't. You may have heard of SMTP. There's that's for email, right? That's the how you send email, or can. And then you've got your presentation, what they call the presentation layer. That's the media stuff. So JPEG, video, streaming, those types of things. That's the layer in which you get that. The reason it's on a lower level, well, is because you need a little bit more interaction, right? Because there's a lot more bandwidth. Typically, they're larger files, and sometimes they're multi-part, so you have to do a little bit of negotiation back and forth. Then you got your session, and then underneath you get that dotted line, right? And this is where it really starts to break down into more of the physical layer. Very, very rarely will you as a developer ever go below this level. I hope you don't have to, because this is where it gets really rough. I'm sure Clayton loves to live down here, because this is what Clayton does. But for a guy like me, I just give stuff to Clayton if I need stuff done at this level. And so you got your transport layer. You've got that's the bits and bytes, how that stuff gets put together and flow. You got the network level. This is where all of the IP stuff comes into play, like how you get your bit masking and everything going on. And then of course you got your data link. This is now getting to the point where you're basically at the hardware layer, almost to the hardware layer, where you're actually worried about where the things are being routed, the physical aspects of it, and that interface between the physical and the firmware version, and then of course your physical. So this is where all of the actual electrons start to come into play. So this entire OSI model, you can imagine, there's standards at each level, and amazingly, everyone kind of follows this, and that's exactly how we're talking right now over Zoom. It's pretty amazing if you think about how complex it is. And how big this stack is, and knowing, especially us all out of automotive, know how standards go. The fact that this actually worked, and we are all talking very consistently all the time, and it just works all the time, most of the time, it's pretty amazing if you think about it. So this is the basics. So now that I present this, not that you haven't seen this before, I hope you have, but I present it now that we've actually been through this a couple times. So you're now starting to understand and see, all right, now that we've built our cloud, now that we've built our front ends and everything, this is what's actually supporting all of it. So just kind of coming full circle. So where you've done this before.
Quick question, sorry if I can interrupt.
Yeah.
Yeah, when we talk about accessing internet, say for example, you were using Google's example. When we put the URL and it assumes port, if it is SSL, it will be 443, or 80 if it is unsecured. It means port at server end and the client from where the request is being made, both are 80.
Both are encrypted. So is that your question, or?
No, what I'm asking is when we say port number 80 or 443, the server end, or?
I see. No, that's a really good question. No, they're not actually. Only the remote is. So it is true. It's what we call a source port. So my computer might be communicating with Google. I'm hitting that remote port of 443 or 80, but I also have to have a port, right? And typically those are above, I think, 143. So typically your computer will choose a port at somewhat random, but something. So basically a port that is unused at that point, and it will actually communicate. So there is the case. It would take 65,000 used ports or plus ports, right, to get to a point. But you could run out of them with number of connections, if you wanted to. But yes, that's what we call a source port. You can communicate from a source port, which oftentimes you do, right? I mean, you have to, because you do have to start from a port. But you will never, rarely see, unless you're a DDoS attack, you will rarely see 80 to 80 or something along those lines. Good question. So let's talk about the HTTP request. So we've been doing a lot of HTTP requests over and over and over, actually. right? I mean, our cloud that we developed, these are all HTTP requests. So our vehicle in Sumo that's driving around, that thing is communicating via HTTP up to our cloud. Our cloud's processing it, saving it, and then returning a response back to the vehicle, right? That's in Sumo. And we're using HTTP for all that. We're actually using a modified version of REST. Not really even modified, we're just using our flavor, a very simple flavor. And you might have heard me mention that, but we're using RESTful web services and kind of the underpinnings of that. In the next few slides, I'm going to start getting into what RESTful services are, because this is where you start to now, you start to depart just being able to make things communicate. And we're starting to add structure, we're starting to add paradigm, we're starting to add style, so to speak, to our APIs. And what makes you, what really separates the standard engineer who knows enough to be dangerous making these web APIs, which is actually pretty rare, and actually gets you into more of a stylized and very consistent way of development, which is where we really want to start heading. So, what's the anatomy of an HTTP request? Well, an HTTP request has an operation. You'll hear me say CRUD operation. CRUD is CRUD, stands for create, read, update, and delete. In terms of the HTTP operations, they're get, which is read, put or patch, which is update, or sometimes not, post, which is create, and then delete, which is delete, of course. Inside of that is the host, and that is basically your URL, right? Or your IP address. User agent, which most things follow, some things don't. You can do user agent spoofing. We'll talk about that in a bit. And then an accept, what the client is willing to accept in terms of format. So if I say, look, hey server, or hey cloud, I expect JSON back, I'll actually put an encoding in there that says, hey, I want to accept JSON back. Or HTML, I'm a browser, I expect HTML because I need to parse it. Give me HTML back. And so you can, what we call MIME types. You can look up a little bit more about that. So this, if you think about TCP/IP, what is it? Well, it's just a medium that carries data, bits and bytes. Those bits and bytes form text, ASCII text, and you basically send ASCII text over that line. It's just language. Just like we speak English, all you're doing is sending words. It's the same thing you do in the lab, right? Those of you who've messed with RS-232 or UART or any of those things in the lab, you're just sending commands back and forth. Typically, they're somewhat readable, even human readable sometimes. Well, HTTP is amazingly human readable. And so when we talk about HTTP operation, you structure a string, a header of get, and the version of HTTP, this is 1.1. Say what host, I'm going to want to do Google. My user agent, which is, in this case, I'll say it's curl. Curl is a command line utility for doing HTTP requests. And then accept, which is I'll accept anything. That's what this example says here. And so, in a sense, you can think of an HTTP request as being opening and closing a socket every single time. We talked about that in terms of performance implications before with our Sumo stuff and everything else. There are other parts of the HTTP response, though. So what we just talked about is the request, what you send to the cloud as a client, what you send to the cloud in order to set up and get a response back. So what does the response look like? So what does a server typically respond in the context if they're speaking HTTP? Well, the first thing is a status code. Second thing is the content type. So you can, as the client, say, hey, I'll accept HTML, but it doesn't necessarily mean the server will send it back. But what it can do is set the content type. So if the client doesn't say or can accept multiple kinds, the content type defines what the server is sending back. It's up to the server to set that. So whether it's JSON or XML or HTML. Then you have a content length. That content length is the amount of, the number of bytes that are going to be returned. And then the actual payload. That's where the data is. And that's what we accept on the client side. And so an example of this is 301 move permanently. So 301 is stands for move permanently. I'll show you some more HTTP codes. What the location is, content type, it's sending back text and HTML. Got the date, some expires, got some cache stuff, the server, content length, 219 bytes. Get a few other what we call headers, HTTP headers, which are key value pairs. So the key here is XSS-protection 1. The X- typically means that it's a custom header. That's the server itself that's by convention. Usually that X- usually means that these are custom headers, they're not standard. And then you can see the payload, the actual HTTP payload, which in this case is HTML. So let's talk a little bit about status codes, because status codes are pretty important. So what was it? HTTP status dogs. This is where I always go. Sometimes you'll forget what HTTP codes mean, which ones, because there's a number of them. They're all numbered, and so oftentimes you'll see HTTP 200, and basically that's a response back that says, "Hey, server, just everything's good." It's basically like an OK, right? That's HTTP 200. 201 is to send back a status code. A server will send that back to a client when it's created content. So client post, so they do a post, and then the server by convention will send back a 201. And then by a 20, let's see, there's one that's updated. Updated one, something like that. I think it was like 203, I thought, but maybe not. 204 is no content. It's very rare that you'll see anything beyond 200 and 201. Those are pretty standard. If you get someone who's really following HTTP really, really closely, you'll see a few others in 200s. Honestly, from my perspective, we typically stick with 200s. And the reason, even if we do a created, and the reason is because, I mean, it's rare the client will really care. They just want to know if something's okay. So keeping it consistent on the client side by sending back a single number is going to be a lot easier than, the client caring enough to code specifically to say, oh, when I posted a message, then I expect a 201 back, and otherwise I expect a 200. It typically will just use a 200. A real purist, HTTP purist would get on me about that, but I'm not sure. Anything above 300 starts to say everything's fine, but it's not really the content that you wanted. 301 means it's been moved permanently, so if you get a redirect or something like that, Google, the reason that 301 appeared is because what Google will do is it has basically one big load balancer, as you can imagine, because that's one IP address, right? So that's one server. There is one server handling all those requests, and what it's doing is just a really beefy one, and it's handling it, but it's redirecting you to the right one. So it's not actually processing. Its sole job is to take that really heavy load and just redirect the client to an available server at that time, or available balancer at that time. And so that's why it gives you back a 301, so the browser can follow that link to the appropriate place. It's basically to manage load and all those different things. As you can imagine, Google's a pretty high load sort of service. Sometimes 302 is kind of weird. I've never really seen any of the other ones. 308, I guess, is a permanent redirect. And then you get into 400s. Anything above 400 means that the client did something wrong. Well, anything in the 400s means that it's the client's fault, not the server's fault. So the 400 range is my favorite one to use because it means it's not my problem. What it means is that I did not get what I expected the client to give me. So 401 is a really common one. That means unauthorized. You're not supposed to. And when we get into security, we'll talk about the 3 A's: access, authorization, and authentication. This is authentication failure. So you only give a 401 back when you fail with credentials. You give a 403 back when your credentials may be correct, like your username or password is correct, but you're not allowed to access a resource. So you'll see both of those, 401 and 403. That 403 is more permission based. 401 is, hey, you're not even supposed to be here kind of thing. 404 is very common. That's a not found. You'll see when we get into REST, you'll see people, RESTful definitions. You'll see a lot of designers and architects use 404s to reflect a route or a resource not being found, like a vehicle number, right? Let's say we do a /vehicles /123 or a VIN number. You might, if that VIN number isn't in the database, you may return a 404. I actually don't necessarily like that pattern, and the reason is because 404 could also mean that you're hitting a wrong route, meaning that like vehicles / whatever number doesn't even exist. So I like to reserve 404 to help a developer figure out, oh, I'm only going to get a 404 if I'm doing something wrong, like I can't find it, rather than, oh, I'm actually hitting the right route, but the resource behind it in the database doesn't exist. So that can be somewhat misleading unless you pair it with an error message or something along those lines. So I kind of try to reserve 404s for the truly, like, I did not implement this, this is not a thing, as opposed to, yeah, you're hitting the right route, but you know, the thing you're just not finding. So I typically will prefer to send back a 400 bad request with an error message if the case is you're hitting the right route, but I'm not finding what you actually want from an ID perspective or whatever. These are my opinions, not necessarily. You'll see many different ways to do this. 405 is method not allowed, so that means that you're sending a post to a specific route, but only get is implemented. So sometimes you'll see that, you see frameworks send that back, like Express will send that back if you try to post to a route that's like only a get is defined for. And then a few others you'll see, and then I've never seen it gone. 404, you could probably force that request URI too long. If someone could look it up, how long can a URL be? I think it's like 1024 characters or something, maybe 2048, something ridiculously long. But you know, you might see that. Request entity too large, pretty common, especially when you're trying to upload files. You need to be pretty careful about that, because that can be a security risk or a denial risk, because someone could try to upload a 3 gigabyte file and eat up all your bandwidth. So you have to kind of stop that before it gets out of hand. The other thing is you've got 2083. Thanks, Rudy. So you've got a few others, and then we get into 500s. 500s are really bad, because they're good if you're a client developer. They're bad if you're a server developer, a cloud developer. And the reason is because 500 means that something bad happened in the server, and well, that wasn't supposed to happen. So 500 basic is internal server error. And so that's when an uncaught error happens, or it's you don't handle something. 500s are really nice to find if you're a hacker, because that means that maybe you can exploit that, because the developers aren't handling something correctly. It also means that if someone's getting a 500, it means that I'm the developer of the server. It means it's my problem, which is not cool. You have to go hunt down that bug. So anything above 500 is typically not a good thing. And 400 is not a good thing either, but typically 400s are easily fixable. You just got to figure out how to, easily, rejigger it if you're getting that and you're implementing that. The other thing you'll see a lot of is 502, bad gateway. That means the gateway, that load balancer that you're hitting, is alive, but it can't find the service behind it. That may be, you may need to be. That's actually implementing your business logic. This stuff will get a little bit more clear as we start to talk about microservices, deployment, and those types of things. But I wanted to go through these status codes to really, kind of drive home what we're doing here. So these are the status codes that will be coming back. All right. Any questions so far? All right. Now, all of you know about server accessibility, right? The fact that you can't necessarily hit your computer from somewhere else. That's actually why we used ngrok, right? In terms of that proxy. So you hear me say the words WAN, wide area network. This goes to that remote and local communication, which is what I started with. Wide area network, it means your server's been leased a public IP, what we talked about, and then local area network. It means it's behind a router, and the chances are it looks like 192.168.something. And all the computers, phones, and everything else that are IP communicating, all your little smart home switches, stuff like that are connected to Wi-Fi, they're going to get a 192.168.1, probably something, or .2, something, depending on what your subnet is configured to be. And of course, you can't initiate a request from a server, right? So when you build a server, you basically are at the mercy of the client communicator if you want to get them in. And that's why we do things. That's why we have things like MQTT, and we can talk about it in a couple weeks to kind of get around that. All right. So before we go any further, I want to start talking a little bit about security. We'll have an entire session on this, but this is really important. And obviously, we could spend forever talking about this. And I wish we could, because it's my background. I like it. But we can't necessarily get into it to the depths of what I'd like to. But every good full stack system engineer is thinking in the context of this. So every time you design a back-end route, every time you design a front-end client, you should always be thinking, how is someone going to exploit this? And the first way that someone's going to try to exploit something like this is steal information, right? Because with information comes power. So the very basics of this, right, is encryption. I mean, from the age-old kind of, code breaking and all that kind of stuff, right? You can somehow obfuscate or obscure the things that you are talking about and communicating with and sharing information about. You can probably hide stuff, right? And so one of the ways that we do this is with HTTPS. Now imagine you guys get online every day, and some days you visit your bank, right? Whether you do deposits or whatever, just check your balance, whatever it is. You look at your investments, you do all these different things, right? Have you ever wondered, if you think about, well, let me say one more thing about that. So when you log on, now that you know and understand a little bit about IP, the way the internet protocol works is it actually goes through up to hundreds of different servers around the world before it reaches the destination of your bank, whether it be Chase, Huntington, any of the Fifth Third, Citibank, any of the big banks, right? It could go through a number of different servers. And we know, now that we've implemented a few of these services, there's no magic to it. It's just software that's running these things. Chances are logging some of this information as it pings back and forth, all these IP packets. So isn't there a huge risk there? Can't someone just be in the middle of that, right? Someone could just be sitting with a server, listening onto all these packets passively, just being a good citizen of the internet, moving the packets along faster than the next guy, so he's going to get most of the traffic, right? Path of least resistance. Kirchhoff's current law and Ohm's law works in the internet too. And someone can just basically pick up all this information about your bank account. So how do we stop that? And why does this stuff why do your credentials not get stolen more often? They get stolen, I know, identity theft is a thing, but why doesn't it happen more often? Because you think it's pretty easy to do that. Well, it comes down to encryption. I hope that you are banking with a organization who deploys internet services and web applications that uses HTTPS. So what HTTPS is HTTP protocol, but with that S, which is a secured layer. And what that secured layer is an encryption. What that means is there's a negotiation that goes on between the client and the server, and it's an asymmetric key pair, RSA, which then converts to a symmetric key once the key is negotiated, and then uses AES encryption back and forth between the client and the server. And so even if someone were in the middle of that, it would just look like gibberish to them. They would need to do that breaking of that encryption. And guess what? That encryption is going to take for frickin' ever to break. All encryption is breakable. It's just how much time do you have and how much processing power do you have. So the typical things, AES 256, or even 128 to that matter, it'd probably take on the order of 1,500 years for some of the largest supercomputers to break that. So that's pretty solid. When quantum computing comes around, well, we'll have that conversation. But for now, we're safe from quantum computing because it's not a thing yet. So for now, we'll just say, well, we're okay with our standard encryption techniques. And so what is HTTPS? It's all about keys and certificates. I'm sure you guys have heard about certificates before. I'm not going to go into the depths of this yet. But really, the basic flow here is that a server specifies a public key. Public keys are basically cryptographically signed identifiers, right? These are things that these are like identities. These are like, hey, my name's BJ. That's my public key. That's what I'm exposing to everyone. I'm not going around screaming my social security number to identify myself. It's my name, right? I'm okay with other people knowing it. That's basically your public key. And what the location is, which is just a web address, HTTP web address. The client gets this key of the server. So server just says, hey, I've got my public key. This is who I am. Client, go and grab my public key. Any client that wants to connect to me. Because if you imagine, not every client is able to store credentials for every single service out there, right? So there has to be some agreement to say, all right, well, if I expose my public key, I'm willing to accept anyone who can process my public key. The client gets that public key, verifies the key authenticity with a certificate authority. Now this is where everyone kind of trusts, and you might have heard of things called root certificates. If you go into your browser, is this Chrome or Brave? Let me pull up Chrome here. So if you go into your browser, and we go to google.com, and we inspect, pull up those DevTools, we go to security, you'll notice that you've got this little secure thing here, and it says connection secure, and it's like, okay, great, I feel good, right? What does that actually mean? Well, what it means is there's a valid certificate, and it's signed by a root certificate. It's signed by a certificate authority. In this case, it's a wildcard for Google. And it expires on a certain time, September 29th. It's up to Google to renew that certificate. And if you go down, there's a bunch of different things. So this is a pretty good one. Elliptic curve, public key. Got some parameters. 256. It's pretty solid. Pretty solid. And then what you've got is all the different DNSs that it can be on. You'll notice YouTube, all the different ones. That's a good way to see all the stuff that Google's into and how many Google services you actually use. See all that stuff. And then extensions, and then who the actual issuer is. And so here's your, oops, I don't know what just happened.
The list of DNS is based on your cache memory, or that's default for everybody?
The certificate authority, or the
DNS, when you scroll down in the DNS, you see all the websites, right? Google and all the stuff. So
all of these DNS, this is just based on what Google has basically signed its certificate for. So like this certificate is good for all star.google, all Google subdomains. So Gmail, or Mail, it's also good for YouTube, right? So, and all of these different things, YouTube Kids, YouTube's Education, all of these. And so when you say, is it stored in cache or whatever, probably for speed, but that's really stored in the certificate.
But what if you use some other website which is not listed here? It's not secure?
Well, that other site would have its own certificate. Google's just saying, hey, like I'm using one certificate for all of these. There are other services obviously not on Google, but you would use another certificate that they will have generated. And so basically what we have here is Let me see if I can. Settings. Go to your Chrome settings and you look up certificates. In here, manage all of your certificates, and you'll notice that there's a bunch of what we call root certificates. And these certificates are actually put into your browser. Well, these are not. Yeah, you've got some intermediate certs. So you see all of these different certificates, and all of these, oh, here they are, these global root, and these are certificate authorities. So it's a really big deal if you're a CA, a certificate authority, to get your certificate authority, your root certificate as a trusted certificate built into a browser. That's a huge deal because there's a finite number of them. A big one is like DigiCert. You hear of DigiCert. Let's Encrypt which we will use to generate our certificates coming up. Let's Encrypt is another one that's free. For many years, here's all the DigiCert ones. For many years, they were very expensive to actually get certificates because they had to be signed by certificate authorities. You'd get it from VeriSign or DigiCert or any number of the others. You see some VeriSign. It looks like Visa's got some CAs here, VRK. These are global too. And so all of your certificates have to be signed with one of these root certificates. So that's pretty big deal. And so when we go back here, when we talk about client verifies key authenticity with your certificate authority, what we're saying is I'm verifying that this public key was generated with one of the certificates that my browser trusts. And so when you use a library and it says, well, you have to install your own certificates, well, it means you have to install your own root certificate. That's a pretty risky thing because that root certificate is not necessarily trusted globally. And then the server knows based on the client's encryption from its public key, because the client does actually get its own private key from that public, so you got some symmetry there. And then the secure communication between the client and the server starts. Now I really glossed over the cool part, which is the cryptography of that, but we'll get into that a little bit later. But all of the detail, like you do this every day, right? All the details are taken care of underneath the hood. And that's one of the nice things. It's just a negotiation that happens underneath, and the browsers, the ones you trust, will tell you if it breaks down. Most browsers don't even let you go to a website, right? You ever get that, this site is not secure, right? And then you have to like click through a couple things to finally get through it. Well, the reason is because either a root certificate didn't pass, someone's using what we call a self-signed certificate, so there's no root certificate there. So it may still be secure, but it's not a certificate that we recognize from a certificate authority perspective. And it's also possible that it is just open, meaning it's just HTTP, and so it's unsecure, which you should never be using if you can help it. I make a rule: I don't visit websites that are just HTTP. The only ones that I'll visit at are just HTTP are ones that I make, or ones that I really don't care if the information being sent is open. There's another reason from a certificate standpoint why you can't do, or why normally you can't do HTTPS on localhost, right? Because there's no certificate authority necessarily. And you don't need it. It's all local, right? Who cares, right? You'd have bigger problems if someone was able to do a man-in-the-middle, MITM, which is known as, that's what that's known as, to steal information. So, all right. So any questions about that? All right, so how do actual web services hang together? So all of us, we work in automotive or aerospace or whatever, all work for probably at what point work for big companies. And we use ERP systems, right? Self-service, portal logins, all that kind of stuff. And, these things barely hang together. Sometimes they're single sign-on. Other times they don't work, right? But there's these really massive systems, right, that all kind of hang together. And you have to use your credentials over here for one, and then you have to change your credentials over here for another and everything. Well, the reason is because all of these services, maybe your HR system, and then your procurement system, and then another system over here, your time management system or whatever, they're all using different web services. They all manage different credentials. And so you have all of these different A, B, C, and D all the way around, right? You got your inventory, you log in your enterprise dashboard, you got your, service outage, all that kind of stuff, and sales pipeline, stuff like that. They're all communicating all around. Well, most of the time, those are just either, hopefully, RESTful APIs. Not as many as we'd like, unfortunately, even though it's been around for many years. Most, some of them are SOAP, XML SOAP. We'll talk about that a little bit. Some of them are some custom thing that was made back in the 90s. Things like that. But for the most part, basically what you've got is all of these services barely hanging together, talking kind of through these APIs. And so what we'd like to get to, and what we're doing, is to make all these services and be able to basically wrap all of our individual clouds, what we're calling services, our servers, with REST APIs. Now, what is an actual REST API? Well, REST stands for a really fancy sounding thing. It's not really that fancy. Representational state transfer. I don't know who named it that. That's trying to make it sound more complicated than it is. As scientists like to do. But really, it just means it's a way to structure your URLs so that you can get and create data. And so it's one nice convention. It's not a standard. It's a convention for application programming interfaces, APIs. And I'm sure everyone has heard in their job about APIs, right? You probably use the word API. Whether you understand it or not, you probably use it, right? Or hear someone say it. It's a software architectural style. That's what REST is. It's just a style. And it defines the constraints to be used for creating these services, these clouds. And so typically, RESTful web services use JSON to communicate back and forth. JSON is that language, the way we speak back and forth. Just like we're speaking English right now over Zoom. Zoom you could think of as RESTful, and JSON is the English that I'm speaking, if you kind of want an analogy, so to speak. And so when we say that a web service conforms to a specific convention, you might hear me say that's RESTful. And so we typically say, oh, that's a REST API, or it's a RESTful web service. So that's all that means. It's just a style in which we architect our HTTP APIs. So what does it actually look like? Well, we've actually done them already in week 2 and 3. REST call is simply an HTTP call that's doing one of 4 different HTTP operations, either a create, read, update, or a delete a resource. When I say resource, what I mean is data, some sort of representation. Data could be stored in a database. It could be created in code. There could be an algorithm. It's whatever it is that generates, but it really is just a resource. And so when we think about it, I get HTTPS, myrestapi.com. I don't know what that URL is. If that even exists, someone can check it carefully. You can do, I'm just saying that's an example.com. And now the part that's RESTful of that is the /vehicles/123. Now this vehicles is a resource name, so we're getting vehicles, and we're getting a vehicle by ID 1234. That's this example. It could also be, this 1234 could be a UID. In fact, I mentioned that down here. Typically they're going to be UIDs. A post, we want to create a new vehicle resource, whether it's in a database or something, or in our case, as of like 2 weeks ago, we were putting it into memory, right, in our server. We were storing it in an array. And so we just post to the vehicles resource and say, I want a new vehicle to be created. You might say, wait, where's the data? Well, the data is the payload part of this, and that's where the JSON comes in. We'll get to that. If we wanted to update the vehicle resource of 123, we do a patch. I used to do put a lot. I used to see that. People have started moving towards using patch more because from a verb perspective, patch sounds a lot better than put. Put and post could mean the same thing, right? And oftentimes they do. So you're seeing a lot less use of put as an HTTP verb and more patch. And then delete. Delete, of course, is deleting a resource. I will make one mention here. I rarely delete data. And the reason is because data storage is cheap and auditability is definitely a thing. And clients always mess up. When I say clients, I mean people who are using my API. I don't necessarily mean clients who are paying for work. I just mean clients of the API. And so what I end up doing is I actually might represent it as a delete, but what I'm doing is I'm just flipping a flag on the record in the database. So I'm actually doing an update. But then on a read, I only select the ones that have not been invalidated with that flag. And I do that, of course, for auditability reasons. That's a pretty important thing, particularly when you get into healthcare or mission critical systems. Don't delete data. You might push it off into cold storage, or you might do something along those lines, but you would never delete data. So it's something to consider. When we do a delete, to the client it looks like it's been deleted, but to the server we may not actually delete that record. All right, so the REST content type. RESTful is pure HTTP. You will not see RESTful over any other types of medium. You may see things that look RESTful, like an MQTT. We'll see that in a couple weeks, but it's not RESTful, and we don't refer to it as being RESTful. So REST is still all HTTP. It's just a style of HTTP. And so when we say if there's a content type or an MIME type, we might say, well, a RESTful web service typically communicates in JSON, JavaScript object notation. I said that before. And the content type, remember I mentioned that with our HTTP discussion, is usually application JSON. And so here's some examples, some real examples, kind of. So you got my HTTPS, we're secured right there. Letting the library and frameworks do its work on doing the SSL negotiation, TLS negotiation. MyRESTAPI.com, someone bought that domain name, registered it, and set it up. And then they put a RESTful web service behind it. In our case, maybe Express. We did that, right, a couple weeks ago. And we're saying vehicles 123. And so this is how the HTTP would look. You got your operation. I want to get a vehicles resource, just a URL with ID 123. My host is this. I will send back application JSON. This is the server. And then I've got JSON. This is what JSON looks like, right? You've seen that before. Post is the same thing. I'm posting to vehicle resource, just a URL. And I'm posting this information, JSON. And I'm getting it just like we provisioned, right? That was just like our provision example back a couple weeks ago. And then we get the response back. Probably get a 200 or a 201 created HTTP status code. And in this case, the API has decided to return the name, so basically echoing back what you wanted to create, but it's also saying, all right, if you need to reference this again, here's the ID of it. You typically always use IDs, and IDs typically UIDs. That comes from our discussion a couple weeks ago. I won't rehash that, but I typically like to use UIDs. There's a security reason for it. There's also a verifiability reason and a uniqueness reason. It will become really clear when we start using microservices and multiple databases. And then we got patching, updating. So we want to update something. Well, we have to update it by ID, in this case 234. We want to update the name to vehicle. And in this case, we've just decided as implementers of our RESTful API that we're going to just return the new record, the new updated record. And then delete. Well, to the client thinks we deleted it, so we won't return the record. Sometimes you'll see it just return back the record that was deleted. In this case, we've said, well, we're just going to delete. We're going to return a status and say what the status is. In this case, deleted. And then, of course, handle other things. So I want to really drive this home. REST is just a convention. I have to this day, never actually seen strictly proper REST APIs. I don't even think that's a thing. Some people, maybe the Wikipedia page thinks it's a thing, but I've never actually seen one. Everyone takes liberties with it. It's just a convention. REST really tends to break down when the route is supposed to actually do something. So if you think about it, up to this point, we've really talked about resources, data. And that's where REST really shines, is in modifying a data resource. But what if you actually want to do something, like activate a device? Well, activating a device may result in some data changes, but really, probably from an IoT context, it actually results in a device switching on over here, or something, right? Something very tangible might actually happen. In the context of a vehicle, right, we might actually do vehicle/ID/drive. And drive is not necessarily a database resource. It's not data. It's a command. It's an action that needs to happen. And so that's where REST starts to break down. I've seen other things. I've seen people try to architecturally define that. And so you might have like an actions resource, and then the actions will refer to, if you want to get really purist about it. What we do is we just relate it typically, and then we'll just end a URL with the action. So in this case, like the vehicle/ID of the vehicle/drive. And then we just know, and we just document it, and it's good to go. And I end here and say, don't be afraid to do something else. REST is just convention. It's not a standard. So don't get all tied up on, is this right? Does this look right? Does it feel right? As long as you're consistent, that's what's important. Just need to stay consistent, and you need to think a couple steps ahead so that you just plan for changes. That's the real thing. So you need to just architect. Don't be afraid to make a mistake, but at the same time, don't get caught up with the specifics of it. And I've seen architects, spend days on their REST APIs, just the format of them, and then you're a week in, and it's like, all right, where's my REST API? And it's like, well, I'm still trying to get this one verb to really feel good to me. It's like, well, you just wasted your week. Should have just did it. So the question is, how do you architect a good API? Well, as it comes down to it, there's a number of different things. The top three, in my opinion, are, the number one is determine the audience of the API, because that's what's important, right? Same thing goes with when you define a product, or usability patterns, or making a web page, or making a website, or just trying to sell something. Who's the audience? So if you're saying, well, my audience is a bunch of engineers who have never used the web before or REST APIs before, you're probably going to architect a little bit differently than a bunch of APIs for a team of developers that have used REST APIs every day. So from that perspective, always keep in mind, how you structure it, what it means, and really what it comes down to is the documentation and the tool set familiarity. Good APIs, from what I've experienced, always have good documentation. And you guys know this, right? I'm preaching to the choir. We're all engineers. We all deal with this stuff on a daily basis. You end up not using shit that's not documented well, right? That's just the nature of the game. So if you set out to make an API, make sure you document it, or else no one's going to use it. You also have to consider what type of data is being represented. So we talked about audience and what kind of documentation you need, but then what type of data is represented? There's the 3 V's of data, right? You probably heard this in big data: volume, velocity, variety. Beth Ann and I have a paper in Utility Grid about this exact topic, written many years ago now. But it really comes down to 3 V's: volume, velocity, and variety. If you construct your REST API, you have to consider, okay, if I have really high volume, maybe a REST API is not the right thing. Maybe I need to consider something like RPC or something. We'll talk about that in a few minutes. If it's really high velocity, REST APIs can hold up to it, but maybe you structure your URLs in a specific way in order to kind of mitigate that. And then the variety of data. If you have a REST API that's massive, well, just make sure you're structuring it appropriately, and you're thinking about, all right, what kind of resources do I have? How do I section this and all that kind of stuff? So that's really how you really think about structuring an API. And then how is it going to be consumed? That's the big one. It goes back to your audience. But you're going to design REST APIs for embedded systems a lot differently than desktop systems. And the reason is because in embedded systems you have resource constraints. Even the length of a URL can become a problem. And so you may start to get a little bit less purist about and beautiful and elegant in your REST API definitions and how they look, and start to cut some corners on how you spell things or the length of them. Or it's like, do I really need this prefix here? Do I really need to say vehicles? The entire thing is assuming a vehicle, and I will never use anything but this vehicle. Do I actually need the word vehicles? Well, to be a good documentation, yes, but embedded device, Clayton would probably be pulling his hair out and be like, I need to now reserve another frickin' 16 bytes just so I can put vehicles because he wanted his REST APIs to be beautiful. Damn him. So sometimes you just have to think about who's actually consuming these APIs and all that kind of stuff. So that's where we're at. So today, what are our options? We've been talking a ton about REST APIs, and the reason is because that's the way most of them are. I really hope we as a community really start standardizing on REST APIs. And honestly, every new system that you see in both enterprise and startups, they have a REST API. You're really starting to see some collection around that, some rallying behind that. You also hear a lot about GraphQL. We won't go a lot into GraphQL. At Technician Modesto, we do a lot of GraphQL. GraphQL is a query language, and it's, I'll pull it up here. GraphQL. It was made by Facebook, a query language for your API. They don't even really call it an API, but it is. And what it is, it still uses HTTP, but it uses one endpoint, and then you send it a query language that looks very JSON-like, but it's really GQL. It's this thing right here. So they still use the curly braces, they get rid of the quotes, right? But it maps to JSON pretty well. And the power of GraphQL is that the client can request only what it needs. And so you basically, and the reason it's called graph is because if you think about putting these APIs together, they actually form graphs. Resources depend on other resources. And when we say like vehicle/ID/ let's say ECU/ID of the ECU. So every ECU hierarchically has a vehicle associated with it, right? An engine control unit always has a vehicle, but you may want to access the ECU inside of that API because you may need data for that ECU. And as you structure more and more of these GraphQL or REST APIs, you start to see graph patterns appear, and these graphs start to come around. And what you find is it would be really nice if a client could just ask for what it needs. It doesn't have to know all these different routes and different documentation. It's basically self-documenting, and that was the attempt. Is the attempt of GraphQL. When it comes right down to it, though, that's a very powerful thing, but GraphQL is really only good at a few things. It's really good at being a query language, a lot like SQL is for database. We'll do that next week. It's just yet another language you have to learn. And it's really good for, well, social media stuff, where you have graph type things, social networks, things where you need to build up profiles, things like that. And you might say, wow, that's a lot of things. It is, but in the end, it's not really. It's really a very specific use case, and you end up doing a lot of boilerplate for this when, in the end, even sophisticated backends, you end up only hitting 3 or 4 different routes. And what GraphQL gives is the power to the client to define exactly what it needs, only when it needs it. But if you really only end up using 4 or 5 routes, even in your final production system, what was the point of putting together this massive, nice query language when you really only need to use 5 things from it? So that's what we've really been migrating. We and taking this over the last five years, about, because GraphQL is probably about 4 years old or 6 years old or something. We shipped everything to GraphQL a couple years ago because we were like, wow, this is great. You can do everything with it. In recent years, we've actually migrated back to REST. We do everything with REST now because we were finding there was so much boilerplate with GraphQL, and while it was great for the front-end developer, it was awful for the back-end developer. And in the end, the front-end developer only used 3 or 4 of the GraphQL statements anyways, right? Queries that it built. It was great for development and discovery and things, but it really didn't matter. So from that perspective, we ended up, we just now have REST APIs. We've also found for those clients that need GraphQL APIs or demand it, that's fine. You can actually generate GraphQL from your REST APIs. Because if you structure your REST APIs correctly, they actually form graphs, and you can just automatically generate GraphQL endpoints for those.
DJ, does that go to kind of your point about the variety topic earlier?
Yep.
So that if you're asking for a variety of data, does that make a little bit more sense to use?
Exactly. If you have a huge amount of possibilities of data and nested data, use GraphQL. But in the end, when you're really just developing really rapid IoT-based kinds of connected product systems, chances are you don't need a massive, plethora of all these different variety of data. So yes, exactly. GraphQL is very powerful. You always consider it as an option. Always talk it through with your team, but in the end, you probably will end up with REST. There's also gRPC or RPC. RPC is old. It came from Java. It's called Remote Procedure Communication or Connection. RPC is powerful in that it defines a specification so that both sides of the line actually implement a method. And so it's really more focused, as opposed to REST that really defines resources, RPC really defines functions and how things should be actually executed on both sides. And so it defines a specification, and then the specification can be implemented on both sides of the API. It can be used. gRPC is known for speed, and so if you have really high volume data, you may actually consider RPC over REST because of open sockets and stuff like that. I don't use RPC very often. If I need something, I'll use like WebSockets or something along those lines to define it. Other things that you'll hear about, and I hope you never have to use, is SOAP and a really awesome proprietary API. Where they, do some crazy ass shit with TCP and, make it look semi like JSON, or they use some version, or send YAML across the line. Said that for you, Clayton. And so, you got all that kind of stuff. I just really hope that you never have to deal with SOAP, especially. We're stuck with our really awesome proprietary APIs in the embedded world. There's nothing, we'll never get away from that. But with SOAP, that was a really old. Anyone ever heard of SOAP before? SOAP XML sometimes? God, this is awful. This stuff was just nasty. You probably sound like a millennial, hating on boomers, but by saying that, because that's basically what the fight between SOAP and JSON and REST is. But SOAP is based with XML, and you know what? I'm sure you've seen XML before. You have probably all written configuration files in XML at some point. XML looks like, give me an example, Wikipedia. Come on, seriously? That's weak. Here's some images. Here, this looks like XML. Everyone's seen this before, right? You got the open and close tags. Looks a lot like HTML. XML is just extensible markup language, just like HTML is hypertext markup language. So you've got all this kind of stuff. You can see how verbose it is. It's just nasty verbose. And the reason is because you've got your tags, you can have your attributes, and then you got your properties here. In this case, I mean, these are all domain-specific language DSL, so you can do whatever you want with them. But you've got these nested things, but you always have this close tag. So where people complain about JSON being bad with the quotes, Imagine XML. Not only do you have quotes, but you got to describe every single data field with open and closing tags of what that data field's name is. And so that's what SOAP was. SOAP was so heavy and so verbose. It's only legacy system. There is nobody developing new SOAP APIs unless they really live under a rock or something, or are so stuck in their old ways they refuse to move on from the early 2000s or 90s. And so you'll see this. So I hope you never have to use it. There's also a ton more, but those are the primary ones you'll hear in the market. So any other questions about this stuff?
Here's a quick question on REST API operations. Yeah, for example, on the you used an example. We did a provisioning using the app.post or using the Express framework on index.js.
Right. Let's see if I can pull.
When you're creating a data and posting it. Now on the client side of it, or rather the embedded side of it, in vehicle.py, with app request.post. So is it that when you're seeking an information, you use .get on the embedded side, or if it's like, for example, here, since it was being provisioned using .post on the server side, it has to be request.post on the embedded side as well, or on the client side as well?
Yeah, a good question. So it's the HTTP methods are from the vantage point, or from the perspective of the server, of the cloud.
Okay.
And so they're also from the client side, right? Because the client's getting information, but the server's kind of saying, look, if you want to get information, then you're going to do a get, and so you have to agree. The client and the server have to agree on that HTTP method. It's not that like the client that the server would implement a post, but then the client uses a get to do that, or something along those lines. It's always at the vantage point of the client. I guess I said that wrong at the beginning. I mean, it's really, hey, I'm defining this resource to be gotten, to be read, and I'm going to just give information. Whereas a post is, I'm designing this route to represent something you can hit in order to create information in my database. And I'm saying my as in this the role of the server. Does that answer your question?
Yeah. And in the case of patch and delete, it would just be on the server side, right? It will updation of information or deletion of information, right? On the client side, you won't be knowing even.
Yeah, well, I mean, the client is the one that always initiates it. I mean, the client always initiates a delete. Like the client might say, I want you to delete this resource. I mean, it has to be allowed to. There's the whole layer of authorization, authentication, and everything. But assuming that the client has permission to delete a resource, it's up to the client to say, hey, I want you to delete this record, or I want you to delete this vehicle record, or something along those lines, or I want you to update this vehicle record. It's still all driven by the client side. The server's just providing methods. It's just exposing methods to act on its data. Now that brings up an interesting point, because servers can also be clients of other servers. We'll get into this when we talk about microservices. So if you think about it, these servers can also hit other servers and be clients of other servers' APIs. And so just because a client is, so if you're like what we'll call middleware server, so you're in the middle of this, so your client is hitting you, but then you have to go hit 3 other servers in order to do a process. You might actually be doing a get on one server, a patch on another server, if you're the server, a get, a patch, and a delete. But then to the client may just say, hey, update this record. But you may have to do a bunch of things with other servers. And so you're the client and using all these other operations, but to your client, it's just one patch, right? And so there's a number of different things that can happen, and you get this web of different things that kind of goes on in a really, and it can get pretty complicated. But it really is, to kind of what you said, the client doesn't really know what's going on. It's true. The client really only cares that the server keeps its contract. And what I mean by contract is that the server's saying, look, when you do a GET request, then my contract says that I'm going to return data of this ID to you. I keep my contract. So as long as you keep the contract, the client can expect that. Same thing with the delete. How it does that, how the server does it, the client shouldn't care about. Those are implementation details. As long as that record to the client is deleted, it can't get it again, it's fine.
So is the client always what is making the request and the server is always the one that is providing it? That's how we define it?
Yep. Yes.
Does that relationship ever reverse? Like I said, I know you said that a server can become a client, but do you ever have where this goes both ways in a relationship, or is it always one way that this is going essentially?
In business applications, it is always one way. It's very rarely two ways. When you're talking about like browsers as clients, I'll take that back a little bit. If you're talking about two massive, systems that are, both servers, one acting as a client sometimes. But business applications, it's pretty much never. It's usually one way. In IoT and connected products, it's not. Because if you think about an embedded system, that's actually the source of truth in many cases. So like if you think about a vehicle being an embedded system, that vehicle really knows what's going on best. The cloud doesn't really know what's going on. And so the cloud may need to interrogate the vehicle to say, hey, what's going on? Tell me what's going on. And so in that case, the vehicle actually, that embedded device kind of acts as the server. May not be as powerful or structured in the same way we typically think of as cloud services, right? But it may need to. And that's when we use things like MQTT as opposed to HTTP. And we'll use other things that allow us to keep a socket open and keep a communication back and forth. You're never going to necessarily define an embedded system with a REST API. You can, but it's not recommended.
So are you going to get data? So normally then, if the request is being made, then the data is coming from the server to the client. The client makes the request, the server then provides it. In an AV system, though, I assume that that you really do have data flowing both ways.
Yep. Oh yeah, you have to, especially depending upon environmental type feedback, right? So if you're not just from a V2V, but a V2X sort of situation, V2I situation, you certainly need that because you may need to know 2 blocks ahead what the traffic pattern looks like, so you can optimize your fuel economy at that point or approaching it. Things like that. That you need a complete and a constant communication, string of communication. And then in those cases, yes, you would end up having, multiple different sorts of, communications back and forth, an open socket, constant communication, very efficient. You wouldn't be opening and closing a socket and doing HTTP back and forth. You'd be doing something like MQTT, or WebSockets, or in some cases, you'll hear about these, once again, proprietary protocols that people make that are really efficient, that are maybe using UDP versus TCP, and sending these things back and forth, and all this kind of stuff. We'll talk more about that when we talk about MQTT in a couple weeks. But yes, you do see back and forth, especially in AV systems. You have to. All right, cool. Any other questions? If not, let's take a break, and then we'll get into OpenAPI, and we'll get some coding. Cool. Let's meet back here, and oh wow, look at that! It's almost like I planned it. Come back at 10. Let's pretend like I planned that. So what happened to your network card, Clayton?
Well, it turns out, although it took me a long time to figure it out because it was only on my machine, that it just slowed down to absolutely nothing. All the other machines on this local inside my office network were fine, and the outside was fine. And so I set up another box, and then when I got that box up and going, I was having the same problem. And it turned out it was another server on my local net here. And it was doing something that was causing so much traffic that it just blocked out the switch. So it ended up jamming the switch that everything's connected into. I don't know. So I just booted all my servers and it ended up clearing it up. But you know, that was after I spent hours putting a new computer together. But
Of course, that's how it always works, right?
yeah, right. Well, the nice thing about Linux is I just moved over my personal folder and it still had all my, you know, like so for Chrome, you know, had all my bookmarks, had everything in there the way I wanted it. So it wasn't that big, but anyway. Yeah, I've never seen that happen before, that it completely jammed up the switch. And
You sure that there wasn't something in there that was spoofing and doing a DDoS thing? That sounds pretty suspect.
Yeah, that would just be really hard to happen. I mean, because nothing comes in, you know, really, you got to go through 3 layers. I mean, it's just Debian, so I'm not running anything out of the ordinary. And then you've got to come in through several layers to get in there. And
Just wondering if there's like a library exploit or something you're running.
I don't, I don't really have any. I mean, there certainly could be, but I don't really have any libraries that aren't, strict Debian, in the Debian system, which, those are pretty secure. So I don't know what happened. Although those servers have been running, that one's probably been running for 2 years. So you know.
Yeah,
I just rebooted and updated, and it
that's good.
cleared it out. So I
Hey,
don't know.
let's start this thing again. All right. One question: has anyone actually been able to use anything yet at work that we've learned? Anybody? Maybe.
I've started building a website.
All right, that's good. Good start. We really haven't been doing this long enough for you guys to do that, but I've been impressed if you're able to, start doing that, or at least sound smart in a meeting or something. All right, so let's talk about OpenAPI and JSON schemas. So someone might ask, is there any standards out there for REST APIs? REST is an architectural style, but is there any standard that really helps me kind of format my JSON and into a specific pattern in order for just making life easy and everything? And yes, there is. We're big supporters of it at Modesto Technicity. There's a standard called JSON schema. We're up to V4 on that, and OpenAPI, and they're somewhat similar. They kind of work together, not really, but they're close. And OpenAPI version 3 is finally close to JSON schema version 4. You can read all about it. I do a couple of different links there, but let's let me show you JSON schema. So JSON schema is basically a way of defining, from a metadata perspective, the stuff that's in your JSON. So it's actually using JSON to define a JSON structure. And so you've got title, properties. The properties within this our first name. First name is of type string. There's a description here, things like that. Age would be an integer. You can define minimums and maximums. And then this is the data that you would send it that conforms to this specification, right? Pretty straightforward. We're used to this type of thing. You might say, well, what's the use of this? What's the point of that? Well, the point of this is because we're always driving towards more generation. We want to generate code. We want to be able to generate more and save ourselves a lot of time, especially when it comes to documentation. So if we can help ourselves auto-document like this, not only can we generate documentation, but we can also generate validations and things and clean up our code and save us a ton of time, especially from like a security perspective or just a usability perspective. So we can actually make our APIs be enforced by JSON schemas. That's what we're going to write here in a bit. So here's an example of a JSON schema. And then there's OpenAPI. And OpenAPI looks a lot like JSON schema. It's very close. Version 3 of OpenAPI is very close to JSON schema version 4. There's a few minor detail differences in how the structures are, but they're all pretty similar. You can kind of see this. The thing that OpenAPI brings is a correlation, or a standardization, I guess, around REST APIs and HTTP methods. And so OpenAPI defines another layer on top of JSON schema that basically allows you to define URLs and here's your base paths, your ports, but it also allows you to specify content types and there it is, responses. So here's our HTTP status, right, 200. Description of it, the content, it's going to be application JSON, and then here's the schema, and then the schema looks a lot like JSON schema, what we just talked about, because it is. And then you have pets, then you have a get, Then you can have a post, a patch, a delete, any HTTP method. So you can start to see that OpenAPI starts to really define very consistent strategies for RESTful APIs. Now, what can you actually do with these? Well, here's an example of a, I've been mentioning DDoS a lot, distributed denial of service. Don't worry about what it is, but right now, but it's cybersecurity oriented sorts of thing. But this is an example. This is a system I wrote. It's an open source system in the cybersecurity community. And what it defines is a REST API. So you can see that I can add an organization to this API, and I can get one organization, and I would expect this information back. And this is all based on OpenAPI. So I generated an OpenAPI spec, and it in turn generated documentation. It's auto-documenting. I didn't have to write any of this. It's just a tool that I used. So it saved me a ton of time. It makes it really nice in terms of all the different stuff. It gives, all the different things. So anyone wanting to use this API can just get this information and consume it. We can also generate software development kits like SDKs, client libraries in different languages to consume this, right? Because now there's somewhat standard. So what is this? Well, it actually turns, that is just a website, but it really is just OpenAPI.json. And it's this thing. And this is the OpenAPI definition. And unfortunately, for whatever reason, oh, I know why. I'm not using, I'm using Brave here. I think this will, oops. There we go. So the format, right? OpenAPI, and you'll start to see this get organization that I said, or this. Let me do one. That's, oops. So this autonomous system, right? Get one autonomous system in the list. Well, that's what this is, right? Get an autonomous system. It's got an operation ID. It's got parameters. It's got responses. Successful response. It references another schema, right? That's also in this file somewhere else. This is just OpenAPI standard. You can see that it also has it will respond to 422 if there's a validation error. So instead of sending back a 400, I send back a 422 in this case. I'm using FastAPI in Python actually as a backend. I also have a Technicity SDK name. What is that? Well, that's my own method, but I use that because I actually generate client libraries for my front ends that will from this API, and then this is how I tell it so when it consumes this API and builds my little SDK, my software development kit, what it does is it takes that as a name. And so here, this SDK name, get identity token. So that's the method name in the language that it generates this API definition for. So some things that we do generally. So I wanted to kind of tee that up. What we're going to do is we're going to take the system that we defined last week and the week before, and we're going to add JSON schema and then an OpenAPI today. So that's what we'll do. So we're not going to add any new concepts, so to speak, in terms of all this stuff. We're just going deeper now into how do we better define. So we're not going to add any routes or any of that kind of stuff. We're just going to add things to the routes we already defined, specifically like one or two of them even. All right, so got all this kind of stuff. All right, so I've got my my folder here. I am going to hang with me here just a second. So I'm going to go to GitLab. I'm going to clone week 3 here. And let me see, don't I have, So Justin put up all his intro stuff, right? So I'm just gonna, you guys have access to this. I am just gonna pull this. So I'm gonna git clone week 3. And then I am going to open up my Visual Code here. I'm gonna move week 3 into a folder called week 4. I'm gonna go into week 4 and I'm gonna remove the .git folder because I'm going to restructure this. And then I'm going to do git init. I'm going to create a new Git repository so that I can then push this up as week 4 into the resources. So that's all I did there. Nothing crazy. You don't have to do that necessarily, unless you might want to, because you might want to create your own repo or something. But just remember to remove that Git folder if you want to create a new week 4. All right, so I'm going to open up Visual Code here. I'm not going to do it in a development environment, and the only reason I'm not doing it in the development environment today is because I've got a pretty heavy data pipeline processing load going on right now. I don't want to add to that because I want it to get done by tomorrow morning. So I'm going to do this locally. Let's see. Basically have a number of different things we want to open up here. So let me start the cloud. So I'm going to go into cloud, do an npm install. So that'll install the cloud here. Nodemon, what do we have? Index. Cloud listing on 9500, so we're good there. And then we got to open up our clients, cd space clients. And then this is Python, right? So I have to create a virtual environment. And I need to pip install my requirements, right? And so if I do a Python, what do we got? Main. I could create 4 vehicles. Well, that's working. That's good. I got to run the, we can run the front end if we want. But really, it's the embedded that I care about because we're not going to be doing much with front end with this OpenAPI stuff, at least initially. So let's do this. Let's just go into the embedded. And I need to do this first. I'm on my Mac here, so I have to export this, and then this is also Python, and then I'm going to have to activate my virtual environment and then install my dependencies. Activate that, and then pip install my requirements, and then yeah, so and then Python vehicle, right? Let's see if it works. Here we go. Nice. From scratch, it worked. It's always a good feeling. All right, so you see that? We're doing that. Okay, so let's look at this. Now, in the vehicle, we're generating all this data, right, in this out. Remember that? We've got our speed, we got our acceleration distance, some acceleration, some position stuff. And we're hitting this localhost 9500, port 9500, our backend server, on this RESTful route, vehicles, vehicle ID, and data. Now, we could very easily do this. Right? Just whatever we want. Don't look at what I'm doing. All right. Pretend like I didn't do that. So we've got. Does that still work? Yeah. Okay. And so we can still send data up, and you'll notice that this data here is coming into our server. Now, do we save it? We actually do, right? So if we actually got that data back, so if we ran our front end, we got that data back, that would actually be stored in our database, taking up space. But if you think about it, it could be even worse. From a security standpoint, that's not really great, that any client could send whatever the hell they want. Now, obviously, this API is awful because we don't even have any authentication or anything, but pretend like we have some sort of credentials, right? And that only, so as long as you get those credentials, a developer, not even being malicious, could accidentally do something that could cause an issue within our backend. So we need to be able to gate this. We need to write code in order to say, look, I only want timestamp, vehicle speed, acceleration, distance, position X, position Y. I don't want any other things. Oh, and by the way, I need to require some of these. So in order for this to be valid, this data post to be valid, I want to always have the embedded, I'm going to demand that the embedded vehicle always send me a timestamp, and it's always going to send me a vehicle speed. The others are optional, but I always want you to send timestamp and vehicle speed because my models depend on it. Or my V2X depends on it because I can't make a good prediction for you down road with the optimal traffic configuration or something, right? So I absolutely need you to send me those. You know, developers will always make mistakes, right? They will always use your APIs in ways you don't want them to, guaranteed. And so you need to do as much as you can to stop that from happening. So what are some of the ways we could make sure that doesn't happen? Anybody? Anybody? OpenAPI, obviously, but not OpenAPI. If you didn't have JSON schemas or OpenAPI, we're leading that. Obviously, you know that. But what would you do otherwise? Anybody?
Can you ask it? Can you ask like a question and tell it it's got to respond with certain things before you'll go forward? Like make it so that it's essentially not allowing the program to run?
Sure. So this is the route we're worried about, right? So this is, you got your /vehicles data post. We're on our cloud, right? So really what we would have to do is we would have to write code to handle all of that, right? We would have to say, okay, we'd say if rec.body.vehicle speed, so if that doesn't exist, then we got to do return res.status code of what, 400 maybe, .json of maybe an error. We're now defining our own stuff here. You need vehicle speed. But then you got to do that for every single one of them. That really starts to dirty up your your stuff, right? Because this is really just boilerplate in the end. Like, that really doesn't add any value to the meat and potatoes of it, which is this. In our case, it's simple, but in any other system, that can get pretty long. And so you really want to focus, right? The thing about maintainability of code is you want to try to get it down into as few of lines. And I'm not talking about aiming for less lines. What I'm talking about is breaking and decomposing functionality and responsibility as much as you possibly can. Monolithic functions are not good. Everyone, you should only do what you need to do in the smallest amount. And the reason is of course, it's elegant and all that kind of stuff, but more importantly, it's about maintaining. Developers, like, if I leave my code for 2 days and I come back to it, it's like someone else wrote it, right? There's like no way that I'm going to remember what I did. And so the simpler I can make it and the more obvious I can make it, the better. Now imagine if I can't even remember what I did 2 days ago, a new developer coming in behind me to maintain it, they have no hope, right? So it's just perpetually, creating more and more what we call technical debt, right? Tech debt. We all know that within the context of our own subject matter expertise. And so it's really bad in here, the same way it is in any vehicle design or any of that kind of stuff. And so we always try to focus on it. So you can imagine that in just this really simple thing, we've got a bunch of rules that we have to write. We're writing them for all of our APIs. We got to maintain all of those. It's going to be really awful, right? So is there a better way? Well, of course there is. We just talked about it, OpenAPI. So are there libraries and things that we can use? Well, there is. And this is where middleware and stuff comes in. Express middleware. It's one of the things I really like about Node. All right, so let's look at stuff. There's got to be libraries, right, that help us do this. Well, one of them is called AJV. And it's AJV stands for Another JSON Validator. There's a ton of them, apparently, because there's another one. This is one of the more popular ones. Where is GitHub link for it? So NPM, we're going to search for AJV on NPM. And what it's going to get us is a really nice way to validate a JSON schema. So we only have to write a JSON schema, and then it does all the other work for us. I don't care about performance. I care about using it. So getting started. All right, so it looks pretty straightforward. We just have to require it, and then we can validate, or we can even do it with less code. I'm going to stick with the less code thing. This is better because it's going to be faster. You want to compile your schemas first, but let's just do this for the sake of time and complexity here. So let's get this going. All right, let's first define our schema. I'm going to create a new folder here, and I'm going to call it middleware. That should become clear pretty soon why I'm doing that. I'm going to create a new file called schemas.js. And this file, we're going to import our schemas. So we want to define a schema for this specific post. And so if we do that, we're going to say module.exports is equal dot, let's call it vehicle data post schema. So what I'm doing here is I am doing this. This is a Node thing, the Node.js thing, where we're exporting a variable from this module. So we created a new file called schemas.js, And we're saying we want to export this variable so I can import it back where I need it to. You'll see how that works in a bit. Module exports, and I'm just saying vehicle data post schema. So what does that look like? Well, I want to write a description for it. This is vehicle data post object, and it's of type object. And it's got properties. First one is timestamp, right? And the timestamp is of type integer or number. We'll just do integer. Timestamp. And then we also have a vehicle speed, right? Where are these coming from? It's a number. Well, they're simply coming from this, right? We're just defining the JSON spec for our vehicle post. We've actually got a number of others here too. What is it? Acceleration, distance, position X, position Y. So acceleration, distance, position X, and position Y. Those are all numbers. It's something is required. Let's say we want to require, what did we say? Timestamp and vehicle speed. And do we want to allow additional properties? Meaning things additional to this, like something crappy, my bad data? No, we don't. So we say false. And there's our JSON schema. Relatively straightforward. You can also add descriptions in here, which can be nice for documentation and stuff like that.
So BJ, does that take, so it says that I'm requiring the timestamp and the vehicle speed.
Mm-hmm.
Is it still going, and it's discarding other properties, but what does it do about the acceleration, distance, position X, and position Y? Is it say, will it still keep those? It won't say discard them, but it won't require them either.
Correct. All it's saying is that if you're sending me something, you better send me timestamp and vehicle speed at the minimum.
Okay.
You can send me this other stuff. That's fine with me, but you absolutely need to send these two things. And you can't send anything other than the things that I've listed here. So it's really just a spec, right? It's just a specification. And it's just an object. So we're basically just, it's metadata at this point.
So do you always have to specify what data you want? Like you can't really go and just get anything you want then, or anything that's generated. You really have to say, or I mean, I suppose you can get anything that's generated, but you may not want it.
Well, that's what AI is for, right? It's going to replace
Right.
all developers. Yeah. So, yeah, that's a human has to write this because this is our application, right? All right. So we've got. We haven't used this yet, but let me import it here. So I've got const. I'm going to require my middleware /schemas. I'm going to require vehicle data post schema out of that. So that looks kind of weird. So I require, this isn't weird. This is just saying, all right, of the same level, I want to go to the middleware folder, I want to import schemas. But then I'm doing like this curly brace thing, right? Well, what I'm doing there is I'm destructuring, what I'm calling destructuring, because as it turns out, if I take this down and I just say schemas equals, and let me console log schemas, you'll notice that it returned, I just printed out the import from this. It printed out an object with one key of that vehicle data post schema. And the reason is because in schemas, this module.exports, this exports as an object. And I'm just saying, all right, on this module.exports object, by convention, Node knows to export this. On this module.exports object, this vehicle data post schema is just a key on there. It's the same thing as referencing, any other JavaScript object. And so when we go like this, we've printed it out. And so by doing this now, I'm just saying, look, I'm shorthanding it. I don't want to have to select this thing off schemas.vehicleDataPost every time. What I want to do is I just want to destructure it so that now I can just reference it directly by variable name. So if I do that, it just gives me that vehicleDataPost directly, and now I can use vehicleDataPost later in my code. So a little shorthand, but it cleans it up a little bit. All right, so we got that. Now we have to say, all right, well, if we have that, then we need to start talking about validating it, right? So if we do the validation, let me find where my browser was, jeez. We need to basically do this. All right, good. All right, so if we do provision, which one are we worried about? We're worried about data. So here, we want to validate the schema and the data coming in. So what we want to validate is we want to do that vehicle data post schema. So this is the schema that we want to check against. We want to, what data do we want to check? Anybody?
Is that a rec?
Yep, rec dot what?
Is that params vehicle ID?
You want to check the body, right? Because it's the body that's carrying all that information we want to verify. We could write a JSON schema for the params too, but let's just write it right now for the body. So we got that. And then what we're saying here is if it's not valid, then we'll console log these errors. But let's do this one better. If it's not valid, yeah, if it's not valid, then we will do a return res.json of ajv.errors. So it'll return what was actually wrong with that. So it's good for the developer who's implementing it to conform. So the assumption here is that if we run this again, keep in mind we're sending something bad here. It should fail. I hope it does. And it is not defined. See that? AJV is not defined. Well, why is that? Because we need to install it, right? So npm install AJV. There it is. We have to install it first, and then we have to import it. All right, so that's installed now in our package.json. And it looks like we have to do some other stuff too. So we need to import it. We need to require AJV here. It's just another library, just like Express or any of those different things. AJV. I need to instantiate it because it's an object. So I'm shorthanding this. I'm shorthanding this and just instantiating it. And then, oh no, did I just close all that? No. And let's see if it builds. Yeah, it builds, that's good. And we got to run our provisioning. Let's see if that. And that did not, that shouldn't work, right? So let's see what it's, see how that's working. All right, so let's just see what valid is. And it is not valid. Let's see what the errors are. Should not have additional properties, which is what we expect, right? And why was it that we expect that? Well, because we're trying to send this, something crappy, right? My bad data or whatever. So that's what we're trying to send. And what we've done here is we're validating the rec body against this vehicle data post schema, and we're not allowing additional properties other than these things. And so, but we're sending that. And so by saying ajv.validate our schema, passing in our schema, and then validating the request body against that schema, we're able to get this additional properties failure, and it should not have additional properties. And so what we should do is we can say res.status 400, because the client sent something they shouldn't have, and we'll send back what they shouldn't have sent. And so we can run and prime our, and then run our vehicle, and you'll notice that it's sending back this 400. So it's not actually saving. The server is rejecting that. Our cloud is now rejecting that because it does not want to take it. And the reason you might say, well, how do I know it's rejecting it? It's still being accepted here, right? It's still going in at least enough to validate this. But what I did was I said, if it's not valid, then return. And that return statement, that keyword, stops execution. That's like one of the most common things in all programming languages. That return statement stops execution of that function inside that function. And so what we're saying is don't go beyond this point, just return 400 and give back the errors for doing it. And so,
Jay, can you stop for a second? Why do you see the simulation go? Like the simulation is still running. It's still creating data.
right.
But you're asking for that the client is trying to post the data.
Mm-hmm.
And it's saying, I can't post it because you've got data in here I don't want. So it's letting the simulation run because that's occurring on the server.
Well, the simulation's occurring, and the simulation's just happening in Sumo, right?
Right.
And so if we just say, if we do R, so if we try to post this, right, and we can do r.print r.status code, we expect a 400 back, right? So let's do that. 400. But I just stopped it. If we remove that, and then run it again, we should expect, let's see, what
It was kicking out on acceleration before.
was it?
Yeah, I didn't like that.
Wonder why. Yeah, type number. Well, let's figure this out. So we print it out, and then let's print r.json too. That'll tell us what we didn't like with what we're sending
There's
ourselves.
also an extra comma in your JSON. You're out
Extra comma
at the bottom.
right there. That shouldn't matter. Let's see here. Should not have additional properties, acceleration. So apparently it doesn't like acceleration. Did I spell acceleration wrong? I did. You notice that? I spelled it wrong. ACCL as opposed to E. And so our JSON scheme actually had a bug in it. That happens. So let's actually spell it right this time. That's why coding's hard. And let's do this again. That's not going to work. I need to find it. All right. And now we should get a 200. I did get a 200. But I bet we didn't actually return JSON. Let me just do that. And there we go. Now we're actually posting. We're getting a 200 there, right? Because we're passing this correctly. Now we could also try to pass a string for position. That'll fail too. I won't prove it, you know, I can prove it, but you know, obviously that should be obvious. All those different things. And so we're able to do all of that good stuff. So that's a pretty effective way, and a pretty clean way, right? I'm gonna post this up for you guys, so I'll leave that in there so you guys can play with that if you want. So that's a pretty clean way of enforcing JSON schemas, or you know, an effort without tons and tons of rules. So basically, just took all those rules and put them in one library that we can just use. That's pretty nice. Now, I still don't like this. Why? We can still do one better on this. Anyone got any ideas? This is no fun if you guys don't interact. Don't be afraid of saying something wrong. Anybody?
Is it going to have to go in order like it's an if statement and you want to get rid of the if statement? I guess not the valid.
What I don't like is the fact that I have to do that boilerplate stuff in this route.
Right.
I mean, it's kind of like, well, every route's going to have that. It's just nasty, right? And especially like what I care about is this stuff, right? Specifically this. This stuff is like boilerplate. It's got to be there. It's boring, right? That kind of thing. So is there a way to push that out and handle it elsewhere without cluttering up my implementation? At this point, we're doing things for style points here, right? But this really...
Did you do a function and call it?
Yeah. So we could put that stuff in a function and call it. So we do one line. But is there a way to remove it entirely from this? And there is. So, what? How do we do that? Well, as it turns out, we can do this, and we're going to do it in what we call middleware. So technically, let me do an aside here. Why I called it middleware? It's middleware because it's really just boilerplate. If you think about it, it kind of is in between the data that's being ingested and the business code, the application logic here, the actual meat and potatoes, right? It's really middleware. It's happening in the middle. And so that's the reason I created this folder. It's stuff that's happening in the middleware. Your authentication and authorization checks will also happen in middleware. So there's going to be other stuff that we'll keep adding to this middleware folder. So when I let me call middleware, and I'll call it validators.
So you might have a whole series of things that you put in the middleware.
Yep. That
essentially you can pull out of your code to keep it as clean as possible.
Exactly. And most RESTful frameworks, like Express, have this concept of middleware because it helps a lot with architecture and structuring and style. And what basically Express gives us, and really it's actually JavaScript, the power of JavaScript that gives us, being a functional language, it gives us an ability to do what Beth Ann mentioned, and that is, can we just put it into a function and call it? But let's put it in a function and call it, but put it in line with all the other stuff that's happening. And so I'm going to make this validator. So let's do a vehicle data post validator. So once again, module.exports, And I'm going to create another route, almost like that get route. I'm going to say request, response. So that should look the same, right, as one of our functions, our function handlers that handles our requests in. But I'm going to add one more thing. I'm going to call next, another parameter called next. We'll see what that does in a second. So in here, I actually want to do the validation. So I want to pull, where was I? I want to pull this crap out, and I want to put it in this function so I can use this somewhere else. And I can't quite do this because I need AJV, so I need to pull some other stuff out here. Specifically, I need to pull this, and I need to import it here because I need to use it. What else do I need? Well, I also need this vehicle data post. So I'm going to const vehicle data post schema is equal to require, but it's actually in the same folder, schemas. So that makes it a little bit nicer here. So I can actually start pulling out. Hold on just a second. So I can actually pull out this crap at the top of my file. So I'm now cleaning up my main index, the stuff that's actually I care about, the core business logic, and I can keep going here. So I'm going to basically run this like its own little route. Right? Request, response comes in. If it's not valid, that's fine. I'm going to respond with a status 400 return. Otherwise, else, I'm going to call next. And what next does within the Express framework, this is very express. This is the library framework we're using. What we're able to do then is we're able to chain these handlers together now. It's a very powerful thing, right? So you can basically chain all this middleware together, and then your handler, like this, is just another part of the chain. Just happens to be the caboose of the train, right? But of the chain itself, it's just the handler that handles the actual business logic. So the only thing we have to do is we have to import something from validators. So middleware / validators and vehicle data post validator, this thing, and we're going to put it in line with this right here. So as part of this post function here, this post function takes a string first as its first parameter, which is the route name, right? And then it's going to take a route handler. But it takes any number of route handlers. So we can start chaining these together. So you can see first argument's a string, the route, but then we can just keep putting route handlers on. And this route handler is just this guy. Just another route handler. And so we can just keep chaining them together, and then eventually we can just say res.json at the end. And what Express framework will do is it'll just keep executing these things in a row, one after another, waiting for that next function to be called. And then if there's no next function, it's over. So it knows that to be the last one. And so we cleaned everything up, but we were still able to do our validation, just in a very clean way. So this is pure style points. Questions?
Do you gain any, I mean, you're doing it for style so that it's clean. Do you gain efficiency and time with middleware and stuff like that in validation? Or is it just truly about you want your code as clean as possible? I mean, maybe not for an application like this, but when you get significantly more complicated programs.
It's a good question. In terms of performance, adding another function in line there technically is not faster, but it is so minuscule, the amount of time that it adds to do another function call, especially when it gets down to the optimizing of how the interpreter works and everything. It's not even probably worth talking about in terms of performance. It really comes down to what you said, and it comes down to maintainability and cleanliness. And so you know, I might be facetious by saying it's style points, it looks cool, but really it's a lot more impactful than that, and it's the amount of time and money and effort you save in maintenance going forward, especially as you start doing larger development teams and you start thinking about how you architect. When you think about how you architect, you start thinking in the context of middleware. So like identity validation, authentication, authorization, when you start architecting those systems and really thinking about it, it becomes really important. And so if you think about it in the context of middleware, you're able to really effectively think and architect a system. And that's really why it's important, why I'm actually exposing to you this right now, because it's all about, this is about architecture. And it goes beyond syntax and code architecture. You might say, that doesn't matter. I mean, it's implementation detail. Kind of. But this is one of those cases where this is actually very, very critical from an architecture perspective. You actually separate responsibilities and roles, right? Where you say, look, if I can think of it in terms of a system, these are actually two separate subsystems that are working together, right? That's what's actually critical in this. It's all about system think. Developers, even software, computer scientists may crunch these things together because they're not thinking in terms of systems. We as engineers think in terms of systems. We say, look, this is a system. It's a validation system. It has an input and an output. Single input, single output. Valid or not, body in, valid out, right? And this is a system. What we really care about, saving data to our database or our in-memory structure. So that's really what we start thinking about, and that's very impactful when we start thinking about systems and how we architect systems. If you're constantly thinking in this pattern, it makes the architecture a lot more elegant, easier to maintain, and a hell of a lot easier to communicate, because that's actually the most important part. Can we communicate an effective architecture to the people who actually have to develop it?
And one of those points of software architecture is code reuse,
right,
and minimizing those lines. So being able to condense it down and have a single point to go to when I have to fix something makes it exponentially easier.
Exactly.
So is that one of the things that you want to do, is that when you develop code like this, that you do want to you don't want to have to write it every time from scratch. So if you can pull it, if you've used middleware or you've used separate essentially functions, then you can pull that code and just correct the function however you want it, as opposed to have to going line by line by line all the way through this massive set of code.
Here's an example.
Well,
let's say I wanted to make another post thing right here, right? This route. And it actually had the same validator. It actually had the same JSON schema, which is pretty common. I can reuse this function here. So I can copy and paste this. It may have a different implementation in here. It may not do anything here, but I may want to reuse this validator, right? And so that's a very powerful thing, so that I only have to change it in one place if this changes. I don't have to change it. If I would have implemented directly here, I would have to change it in both these places, to JT's point.
And the other part of that is, can I do a reuse of my schemas as well, where I could tell it which schema to go out and grab and then return with that checked?
Exactly. The other cool thing about these schemas is, as you get more and more schemas, this position X may be dependent on a reference schema, another schema. So you just import that schema into this right here. And so you can start to chain these things together. That actually leads us very well into our next conversation, which is OpenAPI. So, any other questions before we start talking about OpenAPI? So just to recap, we did a couple different things there. We talked about JSON schemas. We haven't done OpenAPI yet. They looked similar, but we just did JSON schema. We use a library to validate called AJV. And then we We did it directly in this function first, but then we separated it out from an architectural standpoint into middleware to promote reuse and maintainability. So that's kind of what we did. The next part is to start thinking about it in the context of OpenAPI.
Quick question, BJ. I guess this is more on kind of the process for you guys, I guess. But does that schema kind of become your contract between developers as well?
That is exactly. So whenever we develop, particularly front end and back end, so typically like on big projects, we'll have a front end, we'll have an engineer on the front end and an engineer on the back end. And what the front end engineer does is he actually develops schemas for his front end. And then the back end developer develops the back end, typically in parallel, and he develops schemas. And then they compare schemas. And they say, all right, let's negotiate. I want to keep this one, you keep that one. So you actually can develop systems in parallel very well if you both think alike, right? Now, on my team, I've educated most of my team, so we tend, not that my way is better than everyone else's, but we tend to think consistently, which helps a lot with speed, right? I mean, anytime you're consistent, that's good. And so typically we basically come within 90% accuracy of each other. And so we're able to basically negotiate back and forth because we agree on how we authenticate and those types of things. Those are pretty standard things that we just share. But then, you know, the data schemes, it's like, here's the data model. All right, here's your contract. Here's my JSON schema, or here's my OpenAPI schema, and go. If the backend gets developed first, that's even more powerful because, like what I did with this, I mean, I kind of did it with myself because I developed the whole system in this example. But this OpenAPI system that I shared, I developed the backend, and then I can go through my own documentation and just be like, all right, I see that I'm going to return this. I need to create a role. So what does that look like? All right, I need to post this and I need to post this stuff. So it's basically a contract. I say, all right, I know that I need to post this stuff, copy and paste it in, good to go. So there's a significant amount of advantage to coordinating between your team members. And even with yourself, like that example is, I developed the entire system, but I still didn't remember because it was like 2 weeks later, a week later after I developed the back-end system that I did the front end. So I didn't remember what I did on that specific route. I was able to very quickly go to my documentation and be like, all right, I know what it is. In fact, it was even easier because I just generated a little library that I imported, and then it gave me a function that told me exactly what I needed to use from my documentation. So there's a number of different things. We'll get into more of that as we develop more down the line. All right, so now you saw this really nice page, right? This front end. Can't get that yet because we don't really have libraries. All we have is a schema, which is nice, a start of something. But how do we generate this? Like, this is pretty cool, this documentation. You don't have to write this front end or anything. Well, that's where OpenAPI comes in. And there's some really nice libraries. I'm going to start with an OpenAPI library done by a guy, I know him, he's at Netflix. He developed like an OpenAPI thing. And at Technicity, we in Modesto, we developed we took his library, Wesley Todd is his name. We took his library and we extended it because we needed additional functionality that it didn't quite support. And so we took it. So what I'm going to show you is his base library. And then later we'll talk about the extensions that we've made. We haven't open sourced it yet. We intend to. We just haven't gotten it to the point where we can open source it yet. But yeah. So OpenAPI npm. Here it is. And you can see it's a middleware for generating and validating OpenAPI documentation from an Express app. It's exactly what we want, right? Typically, if there's something you want, just search for it. It probably exists. That is exactly what we want. And so we basically need to add this library to our to our backend. And this is kind of weird. So he's part of the Express community, and he's starting this convention, but he hasn't quite adopted it. The community hasn't adopted it yet, so he actually does it under his own name for now. But so it's going to look a little bit weird. But this is the reason I'm using this one is because I really like this library as a base starting point. All right. All right, and then check out, do a new branch for OpenAPI. All right, and then go back to, I'm going to install this Wesley Todd library. Why is that taking so long? Jeez. NPM is taking some time. Alright, let's take a look at this while this is installing. So we can import this just like we did that AJV. It's really a similar library to AJV, it's just kind of on steroids. It allows us to basically hook this thing into this OAPI, create an OpenAPI object here, right? We instantiate it. And we're giving it some details like the title of it. And this becomes important because it's going to generate documentation for us. So we need to give it some of that stuff. You know, AI is not quite there yet to replace all of our jobs, right? So we still have to provide some human stuff here, right? And then we can just plug it right into our Express middleware. This app.use, you know, we use that for the body parser, we use it for cores, we use it for our logging, Morgan. We can use this, same thing. We just plug it right in, and then all we have to do is provide a valid OpenAPI schema. All right, so it looks like it's good. Got to fix that. All right, so let's do what that what it said to do. Import this, but we have to import it using this. I don't know why it doesn't lead with that. It seems like kind of a... All right, and then I'm going to copy and paste this. So let's do this. Let's say our vehicle, our vehicle API. Just vehicle API. And then version, just whatever we want it to be. And then what we got to do, we got to attach it to our request handler or our Express. So app.use middleware. So this OAPI, this may look a little bit weird, but you know how we put our function, our validator in middleware? That's all this is doing. It's just putting it in line. We're just saying put it in line for every single route. That's all this is doing. That app.use puts it in line to every single route, as opposed to our example here, where we just did it for that specific route. So it's just basically saying apply it to every single route. Put this OpenAPI middleware in for every single route. So it still builds. That's a good sign, right? It still runs. And now we have to start looking at how are we going to do this. So let's do this. Let's go to our schemas here, and I'm going to module.exports dot, same thing, vehicle data post, but I'm going to do OpenAPI vehicle data post schema, because the OpenAPI is slightly different, right, than our JSON schema. It's got a few things. Let's see. First one is summary. So summary is post vehicle data, and then request body, description. So you're starting to see some of the HTTP RESTfulness come out, right? We're saying request body. I'm already making an assumption it's RESTful HTTP. Description is not an object. Description is post data to vehicle contract, to use a word echoed by JT, which I appreciated. And then content. And the content is what we expect from the API. So we actually expect application JSON. So that's part of that validation. We're validating that we expect JSON to come into us. So we can also maybe say they're a case of an HTML. So we would do text/HTML case or whatever. In our case, we're just doing HTML, and then the schema associated with it is this thing, JSON schema. Type object, properties, all of this stuff required additional properties. So I was able to basically copy and paste that into it. In fact, let's talk about reuse a little bit. What if we just did vehicle data post schema? We could do that too. There's some reuse. So now we only have to change it here, but both places it updates, right? Pretty cool. I'm not going to do that. I want to be very clear. I want to separate, because these things would never actually coincide. They would never live together. All right. So this actually ends up being boilerplate, and you end up templating this out into additional places in your library, in case you're interested in a production system. But
So you would use one of these or the other, right? You don't use them both generally?
you would not use both of them, because we're basically doing OpenAPI, which is like JSON schema on steroids. It's going to give us a lot more. It's going to give us the ability to generate documentation and also communicate a little bit more effectively. It also gives us a few more tools, just because of the power of it. A little more validation, right? We were only validating the request body, but in this case, the OpenAPI is going to validate everything for us, whether it's JSON, the request parameters, all that kind of good stuff. All right, so we got that in our schemas, and let's look at our validators here. I'm going to look at how we would typically do this. Okay. So my problem is I oftentimes so much of my code is generated nowadays that I have to actually go back and look at how I initially wrote this stuff. All right, so so instead of using our vehicle data post validator, to Beth Ann's point, these things never coincide. We're going to use OpenAPI now, but we have to actually validate it. So we're going to say OAPI.path. The only reason I know that is because I know the library, and I have the answers right here next to me. I've got OpenAPI vehicle data schema. I'm going to do that, and it auto imported it up there for me. That was cool. That was my IDE did that. Clayton, that's why we use Visual Studio Code. And I'm not gonna let up on you, man. I want you to use VS Code. We got OAPI.path, and then basically just inserted our middleware there. So you might say, wait, why did you do that? I thought we imported it for all of it. Well, we did, but we basically imported the structure and some of the nice like overall things to it. We still need to actually do this this actual OAPI.path here so that we import the schema for this specific route. All right, so that's good. And then let's see here. We've got that. And let's do this. It still builds. So let's go over here and let's see if we can /docs. Well, no, right? Because we never actually defined what /docs are. So we need to do that. We can do that in index.js here. And we are going to do this. We're going to do an app.use again. We're going to just say docs and OAPI.redocs. Now redoc is the thing that looks like that. Looks familiar, right? So it was that easy. You got a whole front end and everything with one line of code. That's pretty sweet, right? Well, all it's doing is just submitting an HTML thing, and what it's doing is that HTML page is going back up and grabbing the OpenAPI.json. So it also exposes an OpenAPI.json. And look, it's our OpenAPI stuff. Specifically, the schema that we defined in there. And that's all this redocs is pulling. Is this thing. It's got all that kind of good stuff. Pretty cool, huh? That's pretty sweet. That's a lot. And so we're starting to get into code generation now, right? Because all of that was generated for us. We look like real serious pros now because we got an entire JSON. You know, we got a whole front end, and it looks like we spent a bunch of time on it. Well, we literally wrote one line of code and imported a library, right? There's also another format, I think. It's called Swagger, which is actually where OpenAPI came from. I think, yep, Swagger UI. So let's look at Swagger. So Swagger, it looks like this format. So here's yet another UI that you can use. And Swagger is nice because you can actually like try it out. So you can put a vehicle ID in there, and it'll actually hit the back end for you and all that kind of stuff. So that's kind of interesting. You'll notice that that's not good. I prefer redoc actually, or docs. I prefer redocs. That's just a preference of mine, stylistically, UI-wise. But you'll notice that you might have more things. So let's go over here to our schemas, and there's a concept called tags. And let's just do vehicle data tag. So you can.
BJ, real quick. Where does it just pulling only the used APIs then?
It's only pulling the ones that we documented. Specifically that one.
Okay, so it's only ones that are truly used in the code.
Correct. Well, only the ones that I have provided a schema for.
Yeah. Yep. Okay.
Exactly. So I could do the same thing here to this latest data. This would be wrong, right? Because that's not an actual schema here. But what it would do is give me two of them because I added it, right? So that is an exercise to the reader to go through and document all of your routes. There you go. And so you'll notice that I added the tags there, that tag, and you can add multiple tags or whatever. Let's add another one, data tag, and you'll notice that it did vehicle data and a data tag right there. So it's got a nice little, you can section them and organize them, purely documentation, has no impact on the API or schema, but kind of gives you some nice ways to, so if you have like a user section, you have a vehicle section, you have a, brand section, a make and model, whatever, you can organize them and do all that kind of good stuff. There are some limitations to this. We've actually had to build an entire system on top of redocs that will get you into the specific ones because your APIs get very complicated, like in like IOTRY. .ios, which is our managed IoT service. We'll talk about this later. I don't really want to log in. It's okay. We'll go to documentation, and you'll notice like we actually have built an entire like documentation platform that will take you to specific APIs and stuff, so you can see how massive this API is. So you have like notification fields, you got firmware, you got devices, and all those different things. So you can kind of see how kind of in depth these can get. But Redux does a really nice job of kind of generating this for you and doing it. So secret's out of the bag. We don't create all this really nice documentation. Someone else does it for us. All right, so that's pretty nice, right? I mean, it's pretty consistent. It does validate too, and it generates documentation, and it really promotes good API design. It also promotes documentation, reuse, and that contract, which is so important, even with yourself. It's all contract programming is the way to go. Keep the contract. So that went faster than I thought, so that's good. So that's all I was going to talk about today. I didn't want to throw too much on. Next week we're going to be doing databasing. So we're going to talk about MySQL, Mongo, Redis, different data structures and things like that. We're going to hook it to the back end, all that kind of good stuff. So that'll be fun. But you'll see why these schemas start to really play really important parts to how we interface with databases too, all the way through the stack. So, any questions?
I have a question.
Sure.
In looking at a lot of the programs that you do, they have a lot of the same kind of structures and the same coding. Is that something that is inherent in the way that the computers communicate with each other, or is that simply convention? Like, is it simply that we've developed this way and that's how we're used to doing it, so we all do it that way? Or is it that the structure itself is necessary in order for the systems to operate?
Probably a little bit of both. But it's basically me being a one-hit wonder. I mean, that's what it is. It's always worked. So why, if it ain't broke, don't fix it, right? So, I mean, it's a style that we all kind of developed. It obviously comes from a number of different influences. And one of the primary influences it comes from is actually one of our developers, Andrew Palm, particularly on the front end. Very talented developer. A lot of what you see, a lot of the code generation we use actually comes from libraries he's written over the last 5 years that he's been, we worked together. A lot of my style comes from him. Probably a lot of my style is in his code too, when you look at it. So it really comes down to, obviously all the full stack system engineers that have gone through the boot camp, they're going to look amazingly like the stuff that I do because, well, I taught them, right? So, I mean, it makes sense. My big thing is simplicity. Less is more, always. I've worked with a lot of very talented developers who, are, brilliant, but when it comes right down to it, they're too smart for their own good. And what I mean by that is they end up getting so locked around the complexity of the system and how fun it is to make something really complex and abstract. And, it's like a puzzle, right? You get really into it and you overcomplicate things. And then you can't maintain it. Or someone else, or more importantly, someone else coming in, not as sharp as the person who did it. And so, it doesn't matter how smart they were, they may be like, oh man, I have so much respect for this guy who did this code, but they're going to be cursing their name by the end of the day because they literally can't figure out what the hell the guy did, right? So, the patterns you see the way I do, it's been kind of born out of the necessity for simplicity. And you know, a lot of the things, like even today, like moving that function around, or you know, moving it out of that route handler, the reason we do that is specifically for maintenance reasons and the elegance and simplicity. Because you might say, well, that's more complicated. No, it's not. It may look, in this example, because it's really straightforward and really simple, it may look, but I promise you, when we start putting database calls in next week, it's going to start looking a lot worse than that. At that point, you're going to like, well, yeah, I probably wish I would have moved that boilerplate crap out of there. So, I mean, it's to get to something that's even usable from a POC perspective, point of proof of concept perspective. There's very few things that, you know, end up, you know, being simple. The other thing is we're all about speed and leanness, and so, you know, if you can cut a corner somewhere, cut the corner, right? Like, it's refactoring is one of those things that's going to happen. Like, no one writes code that's actually lasts. You're constantly refactoring, you're constantly trying to do something better, or you're constantly changing because your client tells you, oh, I actually meant this, right? So, I mean, it's okay to cut a corner every so often. And you know, just say, look, I know I could do this better if I spent an extra 30 minutes, but it's not worth it. It's just not worth it. And it's always kind of worked for us. So it's being smart, knowing when to make the call on which corner to cut. That's really where the trick comes into. And also architecting for the future, in the sense that you need to be thinking 3 steps ahead on, all right, well, the client's telling me this, or the application or the developers are telling me this, but I know that chances are this is what's going to happen, so I'm going to leave this open. So I'm going to give them what they want, but I'm going to architect it in this way because I know that it's going to probably morph into that. And that comes with experience. I mean, you know, that's not, you guys know that. I mean, this is, you just can't do it without experience. But a lot of the patterns that you see allow us for that flexibility. So a lot of the things I do here, and if you look at our code or you look at, you know, how we structure things, generally, typically it's done that way because we know that it's going to give us most flexibility down the line. Or the ability to say, look, I know this isn't going to perform at scale, but if I do it this way, I know I can easily replace it with the thing that I do need to do at scale. That's probably the majority of things you see in our code. You probably see little to-do statements like, this is not scalable, change this.
So does that, because I noticed that you don't put a lot of comments in here. Is this just because we're dealing with simple programs? Because I find that what I'm doing is the programs I'm downloading, the examples that you have, I'm winding up going in, putting a lot of comments in so that I understand what you've done and I understand what it is. Would you, in normally doing this coding, would you be putting a lot more comments in so that you can explain to other people what you're doing? Or is this just depends on?
I think it depends. Okay. To me, code is code should be self-documenting. God, who said that, right? In many ways, code actually is self-documenting if you architect it right. So if you decompose it down into its smallest pieces and you really keep very clear roles and responsibilities in the contract, technically it is self-documenting. You just have to understand how the pieces fit together. But if you do enough systems and they're consistent, then, you know, as a team, you're pretty effective together, because I can be like, all right, why is that failing? Well, go look at the schema. Well, there's the documentation. You know, I mean, it's that kind of thing. Or even better, go look at the documentation. It's right there. Oh, I see. I need a units there. You know, stuff like that. So in many ways, like, you don't need to put comments. However, there are always times where you're doing an algorithm, and that algorithm's pretty complicated. It doesn't even look like it should or something. Then I'll put a comment. But only if it's like, yeah, I did some pretty funky ass shit there. I need to comment this because I know I won't remember what I did or why I did it that way. That's a pretty common thing that I'll do. But if it's standard, like really standard, especially in this kind of stuff, if I do comments, it's for you guys. But for the most part, like this is so obvious, right? I mean, even like doing that, it does like two things. It does one thing, right? It shoves that. So you take 1 second, you read, all right, what's this doing? Vehicles, passing a vehicle ID in that object, data, and I'm pushing the request body. Okay, I'm saving the request body array. Like, why would I put a comment there for that, right? That also comes with experience, though, right? I mean, not everyone in this Zoom call is as experienced in reading JavaScript as I am. So that's another thing you have to be considerate of, is who your audience is. So for me,
But also about keeping it clean as well.
Yeah, I mean, most IDEs, color things differently. I don't like to clutter things up with comments because, yeah, I prefer to just read the code. Mostly, I think I'm just lazy. I don't know.
No, I think the way you name the variables also helps in
Good point.
The
Very good.
people reading the code.
Very good point. You do notice my variables are very verbose, and that's a habit that I've gotten into over the years. Is like I will always err on the side of very verbose variable names. I'm not doing X, A, B, C, right? I'm doing, and this is not for your benefit. Like this is literally what it's going to look like in my production stuff. Like we just have really massively long variable names, and the reason is because it's documenting that way.
And when it gets compiled, they get smashed down into to an object. So that you can make them as big as you want. It doesn't matter. They get put into an array. So
right.
It doesn't matter.
And how many people like to read essays? Other than you, Beth Ann. The social scientist of the bunch. No one likes to read paragraphs of stuff, right? So that's the other thing. Like, they better be pithy if you're going to write them. With that said, I've seen some. I mean, the one place that I'll say you absolutely need comments are on Linux builds. You absolutely need comments on those. Thank you. You absolutely need comments on those things. But that's so complicated. Like that stuff is so complicated. You got make files, you got linking. It's just you got these. It's nasty. So you need a lot of descriptions on what's happening there.
Yeah, I comment everything. So
just
so the person behind me can see what I did.
Yeah, but in terms of the other guys on my team, like if JC were here, JC doesn't comment much. He does if, like me, he comments it if there's something he does that's a little bit funky or complicated, he'll comment. But it'll be like one line. It'll be like, this is what I'm doing here, and in this chunk, go figure it out if you want to. Andrew Palm, the guy I mentioned before, he comments a little bit more, but his comments are more like to-dos. Like, I know I can do this better, so, this is where, if you wanted to, you could improve this. So it's more just, like, pointing to things that it's like, I wish I would have done this better, or whatever. I'm saving time kind of thing. And then Michael, another guy, doesn't comment at all. So, but I don't have a problem with it, because typically it doesn't matter. I mean, I can usually figure out what's going on. So it's really just up to the style. And if comments help you, then use them. I don't usually use the comments, even when they're written. Any other question?
Yeah, got a question. Not really from something what we covered today, but very elementary. Coming back to remote container, when you have this error disconnected from dev container, I mean, do we go back and say container or attached to running container? What is the best way to handle this? Or
I would go back to the container. Say I've got a ton running right now. I don't want to F it up, but what I would do is I would just go back and then just open a remote folder, and it will automatically restart your stuff, basically back where you left off.
I think I kept on trying some other options, like try to reconnect to the running container. Nothing works. I think I should.
Yeah, just like start from scratch, and then it'll open it up. You'll be good.
Okay, thank you.
Anybody else? Cool. Well, next week we'll do databases, so that'll be a doozy, just like the last two. But hopefully today was a little more, a little lighter, a little less stuff, a little less drinking from a fire hose, and a little bit more. Okay, now I'm seeing how this stuff's coming together. You guys feel like it's coming together a little bit more now, or is it like, geez, I still have no clue what's going on?
Yeah, I think some of it coming together kind of from the architecture and seeing how pieces, right, to be able to kind of figure out the architecture, you need to know how each little component fits in. So
Exactly. You're also probably starting to see that the language is not as important from an architecture perspective now. The languages is a tool that we use. And that's why I don't put a lot of emphasis on learning the language. I just kind of do things, and by osmosis, like you learn the language, right? It's like anything. You throw yourself into a culture, and you're constantly forced to learn it, you'll learn it, right? To a degree. And practice makes perfect with it. But it's really more about using the language as a tool and learning the architecture with it, and where the best practices and what language pieces give you some of the things. Like here, Express and functional programming in JavaScript allowed us to do this middleware component in a really nice, consistent way. In Python, you do the same thing. It's a little dirtier, though, because it's not quite as functional. And so we'll talk about that when we talk about microservices and optimization and those types of things. And you'll kind of see that a little bit later. But that's why I'm not putting so much emphasis on the language. And I still don't expect you guys to be comfortable with JavaScript or Python or any of the languages. That's not the expectation. You'll get there. It's more about using language as a tool to really understand the architecture and really start to see how the systems work together and how they communicate. Cool. Well, done a little bit earlier than usual. I guess that's a good thing.
I guess, BJ, from like project to project, how much would you say is like reuse versus new invention type stuff when you're developing a new app for a company?
It depends on the application. We tend to like to go after things that we've never done before. So, right? I mean, we all want to do new things. But we'll also, the stuff that pays the bills, also we'll take on because we know we can do it really fast because we've done it before. So the stuff that pays the bills, probably 90% of it is reuse. We finally, but we've been doing it for what, 6 or 7 years now? We've been through a lot of iterations of stuff. But yeah, 90% of it's reuse. I mean, give you an example. We have a new client came to us, said I need this fast. It was COVID related. We need this really fast, and it's basically like a messaging app, run of the mill messaging app. Typically, I'd say that's so boring. Like no one needs to recreate Facebook or whatever. But we looked at it. The topic was good because of related to helping and all that kind of stuff, and we were able to basically do it in 1 month. So we were able to recreate an entire messaging platform in 1 month. We'd never done a messaging platform before, but we were able to reuse everything. We've developed all the tools. We have all the libraries and SDKs and everything. We basically were able to generate most of it, and really all we had to do was make the pretty pictures with the UI, which were given to us, fortunately. It would have been a little bit more. But we were able to do it in a month, this entire massive platform. So yeah, I mean, depending on the application, probably about 90% of it's reuse. With IoT, we've developed so many services, like iOttery being our managed service, things like that. When someone comes to us and we have an option, we'll say, look, we could do it fast with iOttery. We'll do it with AWS IoT or GCP IoT. We don't need to use iOttery, but we'll use it. If you want it fast, we'll use iOttery. We can get things up in a week or two. So, it really just depends on what it is. But after 6 or 7 years, we have so many tools that we've built in-house and experience that that yeah, it's pretty nice. The stuff that I show you guys here are the fundamentals of those tools. So if you start, after getting out of here and you decide, hey, I want to do this professionally, and you do a project with us or whatever, you'll see, oh, like I don't have to do any of this stuff. It's all kind of there. I copy and paste, and then I'm actually working on the stuff that matters, the application code stuff. I'm solving the cool problems. The stuff you see here is basically the fundamentals of what that is, because I'm a huge believer, not only as an educator, but beyond that, huge believer, and you got to understand the tools in order to use them, because inevitably they will break, or you'll have to modify them. And the minute that happens, you're going to add a week or two to your project that you can't afford. So you might as well. I'm hoping that by going through this, you'll understand. Oh, these are the underpinnings. This is what happens. I can go and fix it now because I can do it quick because I understand what's happening. The other thing, it helps you develop faster because you're not worried. You understand what's going on, so you can catch your own problems faster. It's the age-old thing, right? So a lot of the stuff we do here, it will look the same, but a lot of it's already taken care of. Like if you develop a new system, all of this will already be provided, and you're basically doing that line, that kind of stuff, and you're writing your schema kind of thing. But you're not even writing this, right? You're only writing your schema. This is all boilerplate. And then on the front end, you're not writing those JSON API. You're just importing a library and using that library because that's an SDK generated from the OpenAPI spec that you wrote. So, and we'll see more of this as we go through our 12 weeks. We'll introduce more and more of these libraries and generation things and stuff, so you can guys see how it builds until you get to our big managed services. So that's what enterprise is, right? Enterprise doesn't want people developing custom code. It's hard to maintain. They want you to be using generated things and all that kind of stuff. There's lots of downsides to that. We'll talk about that later, but it's just a natural evolution. But yes, about 90% is probably reused. Any other questions? Cool. Well, I'll post this video and see you on Tuesday. If you guys have any questions. On Tuesday, what I'll do is, if you guys want some homework, what I'd say is I'm going to post this and then what we just did here, and if you would, add some schemas to the other routes, like that provisioning route would be a good schema to write, and other things. Try your hat at that, and come with questions, and I'll probably do a little bit more architecture on Tuesday to kind of show an extended, extended opinions on where this could go, or how you boilerplate this, stuff like that. More language-oriented things as opposed to architecture, but that kind of stuff. So yep. All right, guys. Sounds good.
See you.